no one even makes it a point to ensure good faith. It's literally just like they want it to be a spectacle, and hopefully it gets a lot of super chats or something. You know what I mean?
Well, I
It's
mean,
whack.
you know what they do now, just like what they did with Charlie Kirk or anyone that has a different idea, is they say it's dangerous to public health, right? It's dangerous for mental health, so they shut it down, and no one.
No, Charlie Kirk was a fake character, dude.
Hold up, he
Okay.
wasn't finished. Just hold on.
But either way, the point is, there is no argument to be had anymore, right? If you can just shut it down and say, this is a dangerous idea that's being spread. We shouldn't let people who are promoting this idea have these debate platforms or have access to these platforms because it's affecting society, etc., kids, blah, 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 whatever. Whatever they want to say that it's actually hurting.
But what's
That's
funny
their
is
excuse.
if you applied that same standard to all of like the narratives that are now pushed by the mainstream, they would never have been a thing. Imagine if they shut down any evolution debate, evolution proponent from arguing for his position, or Galileo or Copernicus, according to the official story, or Einstein from, proponents of relativity, whatever. Like, even according to like the mainstream story, if you had adopted that approach, then you would have had none of the like breakthroughs that scientism touts in the first place. It doesn't even make any sense. Same thing with like this real rigid, dogmatic, like borderline cultist and religious um, devotion to the consensus. It's like, bruh, you know, Einstein was laughed out of the room at first and went completely against the status quo. Nikola Tesla didn't even go to school, and his ideas were considered crazy at first. Like same thing with Galileo again, right? And Copernicus. So why? How does that make sense? This is like it doesn't make any sense. It's like the same people that believe in Einstein, they act this way, but if we had approached that with a new paradigm, they'd still believe in Newton. Right.
Right.
So just weird.
Well,
Yeah,
see,
it's almost like a practice what you preach kind of scenario.
Well,
I
it's
think
like
they have.
it's okay as long as it's my belief. Right? Like that's a good thing that people be heard that are coming from outside of the system, as long as it's whatever I currently believe. So yeah, like what you said.
I support the current thing.
Mm-hmm. Think about it.
These
Like, if we're gonna be
PhDs
honest.
though, Witsit, a lot of them are like introverted. Like, I mean, debating is really a skill. I mean, it's not a skill that most people are good at. Doesn't matter how
Sure.
educated they are, how smart they are. It really is a skill, and practice obviously makes you better at it.
Well, I agree with this completely because I think I could debate and quote unquote win for ideas I don't hold or I don't think are correct. But like my point is all the more reason for those people not to even have a say about who does or doesn't do it. You know what I mean? Like I don't know, bro. And like I think if we're gonna be really honest, right? Like there's a ton of people that'll come in these circles, and for example, they defend relativity. They claim it's the most tested and verified theory ever, and da 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 da. Right? The truth is, it's over 100, almost 100 years, people haven't been able to fix the fact that it's not working. And quantum made it way worse. And it's known it's not right. Right. And people try to say stuff like, well, we know there's a little bit more to it, but that doesn't mean it's wrong. No, it's wrong. It's fundamentally wrong. And think about it.
Fundamentally
Those same
wrong.
people, if there were any people that were
How is it?
pushing just a second. If there were any people that were pushing relativity back in the day, the same people that are defending it right now would have been mocking and ostracizing those people because we know that Newtonian gravity is true. They would have done the exact same thing.
Hey, so Professor Parks, I was actually about
Yo,
to post something in chat to see. Yeah, I know it's kind of rare that you and Witsit are both here. Do you guys want to go back and forth for a bit, or?
1 second, I'm typing something in the chat.
What has relativity produced?
What do you mean by produced?
In terms of anything practical or applicable to society and like for a betterment of society?
GPS would be one of those things.
GPS. Okay.
Yes.
Oh, you can't ask that question if you're not ready to rebut GPS, bro.
Well,
Come on.
I'm literally waiting for anything else. Just
The whole
GPS.
satellite infrastructure. The whole satellite infrastructure is set on that relativity. Seems to be like the underlying mathematical technology or something that they're operating by.
I'm sure there are other applications that relativity has a hand in. I'm just not aware of them. For me, my interest in relativity is an academic one. I don't know why something has to be useful in everyday life in order to be true.
Well, if you have a relativity, fascination, like academically, that's one thing, right? And it's like, where do you apply it?
I would apply it in my work if I were looking at blazars, for example. If I wanted to know what the size of a active galactic nuclei was, I would have to include relativistic effects when looking at microvariability of a jet in the X-ray. So for me, it does have practical applications. You wouldn't care about it. I don't think anyone in this room would care about it, but I do.
No, the
I don't even know what you
implication,
said.
the implication being that, what's the implication? What's the point?
So
Because
what I'm
Professor, no,
yeah.
I'm talking to you. I'm not talking to you. I'm talking. Professor
Sorry,
Parks' point clearly would be like that. That's irrelevant in terms of whether or not it's true. Right. I mean,
I know I'm appealing to a pragmatic use case of it, but I am just curious, like what is it in terms of a relativistic paradigm versus, let's say, classical mechanics?
you want me to still man it for them?
Sure.
Okay. So like GPS, right? And they claim that that's special relativity time dilation. And so that the software corrections are based on time differences. Um, and it literally gets allegedly corrects errors based on time dilation. They claim that it's used within like particle accelerators, like CERN has to account for relativistic corrections, like relativistic mass, in order to like apply more energy to the particles or whatever. This is what they claim. Obviously, like relativity is like largely tied in within modern astronomy and astrophysics, right? And this is how they model all kinds of stuff, you know, neutron stars or whatever. Obviously, Professor Parks would be way more adept there. And then not just like GPS, but like the other guy said, satellite communications in general. They also claim that international timekeeping in general utilizes it. Basically, like a large amount of particle physics until you get really into the quantum aspect. They claim they use it for like nuclear energy, if I'm not mistaken. I think they claim that basically the whole foundational premise utilized for nuclear energy is E equals mc squared. Yeah, I mean, atomic clocks, obviously, which kind of does end up tying back into GPS. They would say that they use relativity to detect gravitational waves, which is kind of a super nuanced thing, but and not particularly practical or whatever. But that's really the most of what I could think of. But I
It's a
mean,
pretty good list.
yeah, like I
So
could go down why each one of those are BS, but like it's not really the point. Like for example, with GPS, like that's the claim, but when we started looking into it, we started finding actual anisotropic corrections in some of the data. Some of the what was purported to be raw data, actually, this wasn't nothing to do with flat Earth or anything like that. A team at a university went and like tracked down some of the purportedly raw data of GPS and found out they had already had relativistic corrections applied to them. And so when they claim that they're raw, that just assuming relativity is true, that they applied that correction, assuming that that's just kind of like part of life, right? Like part of the world. it's all reference frame dependent and has relativistic corrections. And that's a huge deal because that's actually like covering up an anisotropic signal, a direction specific signal, which actually shouldn't exist in relativity, which is of course why it's a relativistic correction. Anyway,
Could you
and then
define that real quick? An anisotropic signal, just for
can I
clarity.
find it? No, I don't know. I'm on my phone.
No, define it.
Yeah, I did. I did like direction specific, meaning that the signal goes faster in one direction than the other.
The speed of light is direction dependent.
Yeah, and it's like a small amount, but it's obviously a huge difference when it comes to GPS positioning and stuff like that.
Yeah, see, I've never heard of that. I've never even seen evidence, any kind of implication of that. And trust me, if someone had found that the speed of light was in fact direction dependent, that would be huge news. I wouldn't have to search for it. It would be broadcast. People would be shouting it from the rooftops.
I disagree because it has happened. It wasn't shouted from the rooftops, and the way it was discovered was a university team going and looking at the quote unquote raw data, and then there is like a pretty foundational like manual for international GPS signal that explain this. Alan has it. Alan and all of them have it. Do we still have the like list of papers and stuff like that?
Yeah.
Yeah. Okay. I don't have it on me, but yeah, you can read it. Just point blank talks about it. C plus B corrections, and then there are some proposed relativistic explanations or whatever.
Well,
the beauty about relativity is you can just jump into like, well, let's just like use concepts to make this work. That's what they do with the linear interferometer. How the interferometer detected linear velocity. Well, they just like made up a totally new reference frame, applied a new geometry to it, and then ta-da, make the math work.
Yeah, so the Wang paper, I finally looked into that, and
Nice.
I have no idea why that is being used as any kind of refutation of the Michelson-Morley experiment. All it is stating is that you can see this particular instrument is claiming that you can measure the Sagnac effect using a linear table.
Yeah, it's a linear motion that's detected.
Yeah, that's a problem, isn't it?
And it's not a refutation of MMX, right? It is, well, you mean like a refutation of the relativistic explanation.
It is saying that particular linear device can detect the Sagnac effect.
Well, the interferometer can detect linear motion, showing that the Sagnac effect isn't limited to rotational motion, which is an issue because that was like the relativistic explanation is that you can't detect the orbital motion in MMX because in this reference frame it effectively amounts to linear motion, and then you can detect it in Michelson-Gale-Pearson because it's rotational. But yeah, before I lose it, like the other thing about the whole GPS thing, they actually had to bring Ron Hatch in to make major corrections. They were having like huge issues. GPS wasn't working. So they brought Ron Hatch in to fix it. And he wrote a whole book explaining how like the corrections he used had to like discount relativity and don't work with relativity. And talk about being buried. Go try to buy his book.
And who
like
buried
$400. Well, I mean, they just stopped publishing his book.
Is it a textbook? Is it a textbook?
No. But Ron Hatch is no like random guy, right? Like any book he writes should be readily accessible, and it's not. It's
Not
like
necessarily.
studies. Well,
if it's a niche book, it's going to be hundreds of dollars because the publishers aren't going to produce a mass quantity of them, so they have to recoup their costs in some way. If you look at any sort of academic textbook, they're all going to be hundreds of dollars. It's actually a problem when it comes to the educational system in this country.
Sure, yeah. So like Ronald I mean, like even trying to find like a digital copy was basically impossible. And one of our buddies had to buy the book for a few $100 and then manually copy it, like manually upload it page by page. Pretty crazy. But anyway, the point is that here I just looked him up. Ronald Hatch's entire career has been involved with satellite navigation and surveying, first with the transit system and then with GPS. Ron is perhaps best known for his innovation of smoothing the code measurements with carrier phrase measurements to mitigate multipath effects. Ron was one of the founders of Navcom Technology, a John Deere company. He is currently the director of navigation systems. Prior to joining Navcom and after 23 years at Magnavox, Ron worked as a GPS consultant with a number of companies and government agencies, including among these were Leisha, Honeywell. Honeywell is obviously a very big name in this situation. Northrop, NASA, had to bring him in, and FAA. And the FAA. Mr. Hatch received a BS degree in 62 in math and physics, Seattle Pacific University, blah, blah, blah. He has had a number of positions with the ION and is currently chair of the satellite division. Ron was the 1994 recipient of the Satellite Division's Kepler Award.
Where are you seeing this?
I just looked up Ron Hatch accolades. It's the Institute of Navigation. I'll drop the
Ron
link. But
Hatch.
so
Because I can't seem to. Nothing is coming up on my Astro search or on my
bro,
Google
how
search.
weird is that? How weird is that? How
That's
weird?
the
I mean,
point,
I just
right?
read off his accolades. I mean, it's not like this dude is some slump, bro. Like NASA and FAA brought him in. He helped them majorly. Like, admittedly, he created he
Oh,
he,
here we go.
he helped them fix a problem that they couldn't fix.
Okay.
Would you see that's the kind of point, though?
And you were saying that Ronald Hatch's, when he came in and fixed it, he found that relativity was not applicable in this case.
Yeah, well, it wasn't sufficient. Yeah, like he had to make additional corrections that were not relativistic. And I mean, you're really not gonna like this
But
next
the
part, but
relativistic effects were still needed.
well, specifically the relativistic corrections didn't work. It didn't match. Like if we took the relativity predictions, it didn't match what the satellites were giving us, and that's the problem that they had. And then what he says is that he basically that the framework that he used was etheric, and he actually went as far as to claim it was proof that the ether's real.
Where is this?
His book. I mean,
Yeah.
hey, Beast, do you know about this? Where we did upload Toby back in the day. Actually scanned it.
Oh, it was
All this is
Toby?
on my external. Yeah.
That's awesome. I miss Toby.
I'll find it. We need to keep a list of the stuff I'm going to end up having to give Professor Parks here.
Where did Toby go?
He's just been
he had
busy with real life.
A lot of work.
Yeah.
Work and stuff.
So again, I want to clarify with the relativistic effects of the GPS. Is he saying that the relativistic effects that were added were wrong, or were that the relativistic effects were insufficient given other variables that had not been taken into account? Because those are two very different situations.
They were just wrong.
Okay.
Yeah. I mean, yeah, fine. Like basically, he scrapped it and applied a different framework. That was etheric. And specifically, like we're talking about anisotropic propagation, right? Because like, it's a reoccurring theme. Like,
okay, so actually, this is really what I want to talk about. Is so what you're telling me is that a well-established, respected individual effectively has shown evidence of special relativity being incorrect, has basically falsified special relativity, but his work on this particular subject is being suppressed. Who is suppressing it and why?
okay. I mean, good question. When you ask like who is suppressing it, I mean, it's not really like some like cabal of people like put him on a list and said suppress him. It's just that the conclusions that he came to are not welcomed by academia and the status quo. Right?
Who is
It's
the
very similar.
academia?
It's just like the conglomerate. Like one of the ways this stuff's enforced is like peer review. And then you can look at a good example of it. You can look at the story of Luka Popov.
Yeah.
Luka Popov, and he wrote a paper, about the Newtonian Machian neo-Tychonian analysis of planetary motion of planetary bodies.
Yep.
And
I'm aware.
that was, of course, published, right? Peer review. And like the main criticism in peer review was like, but the Machian principle doesn't seem to be true. And relativity actually requires the Machian principle to be true. So it's a really goofy alleged refutation. But
yes,
yeah, it's just like we know the Earth's not, this is the stillman of that position. That's just like, we know it's not true because it started at go faster than the speed of light. Right? Once you get too far out, anybody that's too far out from the Earth, if it was rotating around the Earth, would have to go faster than the speed of light. But it's not that the Machian principle isn't true. It's just that whatever, it
so
would succeed. Okay.
I'm
Good.
familiar with the academic community and how it works. So what I'm asking is for some specifics as to
Well, I got distracted. I'm giving you example.
who is actually causing Hatch's work to not be published or buried in some way.
Yeah, so I
you're
got a little
saying that-
distracted, but I'll give you an example.
Sorry.
I mean, I can probably learn some from you here, to be honest. But so then what he did, and I learned this, so just like from another PhD that knows him. But then he published a follow-up paper about the viability of geocentrism. He was not claiming geocentrism. He was simply showing a dynamic viability with all the math and physics. And the paper just got rejected outright. And so it's like, why? Like
this is Popov.
Yeah. And not some like random guy, right? Same thing. So it's like, well, we know why. We know why that would get rejected. And I brought that up
Why
because
would it be rejected?
because geocentrism is not a welcomed idea to even be discussed.
So it would be rejected. I don't know what paper. I don't know what journal he submitted it to.
I think I have it.
I believe I've actually seen the paper that you're referring to. I don't know what journal he submitted it to. It may have been. It may have been not appropriate for the journal that he submitted it to.
Same one, European Journal of Physics. Same one that published the first one.
European Journal in Physics.
Well, they published the first one.
I'm more honestly. I'm more familiar with astronomy journals than I am with physics journals.
Do you know of any geocentrists in your field, or like know anybody that's prominent? Okay.
Nope.
Why?
Because all of the evidence is overwhelmingly against a geocentric universe.
Okay, so nobody in terms of your peer group has talked about it as being,
of course not. Why would
viable. Well, that's what I'm just asking, because I'm like,
no, of course not. Look at PhD Robert Bennett. He's a perfect example, right?
Yeah, exactly. We had to wait till he retired.
The PhD Robert Bennett, who wrote he was a professor. Well, you laughing at him, but I mean, he worked with people that worked directly with Einstein. He was well respected throughout his whole career. He wrote his thesis on the relativity and the motion of rigid bodies. And
I have spoken with Dr. Bennett, and his understanding of the difference between dynamical and kinetic physics is honestly embarrassing.
Okay, well,
he does not believe that kinematics is predictive, which is just patently false.
Yeah, I don't know what the context of him saying that would be, because of course that's a mathematical description of what's already been observed. So in that sense, it would be predictive, right?
It is because of Dr. Bennett that I have I am triggered by the term Newton's bucket, because that's all he could that's all he could tell me when I asked him for more specifics about how kinematics is in fact not predictive.
I don't think you're going to like my take on that conversation.
Yeah, I'm sure it is. But to answer your question about, are there any geocentrists that I know of in my field? No, I don't. Now, is it possible that they're in the closet and that they are going to wait till they retire in order to, show their true colors and show that, yes, in fact, geocentrism is correct? That's possible, but again, I obviously Robert Bennett exists, but I did not know of Robert Bennett until I got into the flat Earth community. So I don't know of any major scientist who has done it. The thing is, if you understand astronomy, the idea that the universe is geocentric just does not work on so many fundamental levels that I cannot see how one can reconcile a geocentric universe and being an astronomer. I mean, even the folks over at Answers in Genesis are not geocentrists.
No, who cares? Just so the audience knows, Robert Bennett, okay, he came to the conclusion that the Earth was stationary and that the ether existed many, many years ago. And he had to sit on this opinion until he retired to ensure that he could do so and ensure his pension and that there were no issues. Right. So I bring that up. And of course, now he was immediately labeled as a dissident. I bring that up. And this happens over and over and over, by the way.
Give me another
right?
example.
The guy that wrote the book, Seeing Red,
Alton
Halton Arp. Halton Arp.
Oh, Arp, yes. Okay.
Okay. Once again, not some random guy.
Yeah, and he
Right.
wasn't exactly labeled a dissenter. Arp was someone who vehemently was against the Big Bang Theory, and so was Hoyle, as it were. Both of them were still respected in their fields. They just were not listened to, or they were not given as much credence when they continued to put forward the steady state model, even after evidence that the steady state model could not explain was presented.
So Halton Arp, he is known for the Arp Atlas of Galaxies. So he literally created an atlas of galaxies that were peculiar. They were named after him, or they're commonly referred to with his name.
So you didn't even listen to what I had to say.
No, I did.
Arp is a very well respected astronomer. So was Fred Hoyle.
Bro, I know. Right, you interjected, so I was just finishing that point for the audience. The audience doesn't know these people. And I was just making that point. And like you're saying, he's really well respected and all that. He was basically labeled a quack and rejected as a dissident later in his career. And you can say it was just because of the steady state model, but it was actually because he was extremely vocal about how the mainstream interpretation of redshift was incorrect. And he may have had his own ideas, but that's not even what he was upset about. He was upset that people weren't addressing the evidence that went directly in the face of the mainstream interpretation of redshift. So much so, he wrote a follow-up book exposing the mainstream interpretation of redshift called Seeing Red, which is, of course, a play on the fact that he was pissed because he was being boxed out. He was being boxed out and like labeled a quack after he'd already proven himself, simply because the conclusion he came to, looking at the evidence, wasn't accepted. It wasn't welcomed within the religious dogma of modern cosmology. The implications of something such as the redshift assumption being wrong are so drastic, it's not even considered an option. It will not be considered.
It will be considered, but you have to have evidence to actually back up that claim. Now,
he did.
And there's been more counter evidence. I have not read this book. I am not aware of Arp's arguments, but all of the evidence that we have now is in support of the Big Bang model, the cold dark matter Big Bang model. It predicts, for the most part, basically the galaxy formation, how stars form, how galaxies form, and what we can see in the galaxy today. Now, there are some interesting things happening in the very early universe. However, that has not been a refutation of the core concept of a Big Bang.
Okay.
And you also realize that steady state actually violates the laws of thermodynamics, which you are very much a fan of.
Um, yeah, a lot there, man. You know, like for one, the Big Bang is just a cool story, bro, and it's not even like it's not even polished or like it can't be qualified as a theory. Uh, Ironically proposed by a creationist, of course, because
Well,
the
God.
obvious implication that jumps off the page is that someone made the bang happen. But throw all that aside, the like when statements like the Big Bang model is like everything suggests it and all that, it's like these very like respectfully like sloppy, like holistic claims that just they omit so many things. Like for example, to even like propose the Big Bang in theory, you have to use special pleading. You have to claim an exception to a universal principle, and
Like
then
what?
like the inflaton. You have to basically pretend that there used to exist a particle. Some say field, particle, both, whatever. A particle called the inflaton that doesn't exist now. That's why it would be special pleading.
So
And
you're talking about the inflationary model of aspect of the Big Bang model.
yeah, which is
Okay.
like, I mean, it's baked in, right? Baked in because of the
No,
flatness
actually, it
problem.
came later.
No, I'm
The
saying I'm
inflationary
saying it's
model
baked. It's baked in now. Like
effect.
like
Well, I wouldn't call it baked in. It is definitely a necessary component
well, that's what I
in
mean.
the current in the current model description of the model.
Right.
It's basically was. What's funny is that the inflationary model was added because of the cosmic microwave background. The cosmic microwave background is one of the most solid pillars that indicating that the Big Bang existed. If you look at the spectral energy distribution of the cosmic microwave background, that is the best fit of theory to data I have ever seen. And so, if you're going to say that Big Bang is not, is some kind of kludgy thing that we've just kind of come up or like thrown together, I would like to know how you explain the cosmic microwave background.
Okay. So falsification is an opinion of replacement, but I I can't explain it. But before we get
Dude,
to that, though,
you are making a claim that the Big Bang seems to be just this idea that we're throwing out there and that we have no solid evidence for it. And I'm giving you one of the strongest pillars for it. So if you're going to
yeah,
make the claim that there is
but
no strong evidence for
you
the
did
Big
that to
Bang,
deflect away from the inflaton, right? So basically, I brought up the Big
no,
Bang, and now it begs the question: special pleading, and you said, "Well, it seems to work with the CMB, and I need you to explain the CMB." It's like, well, okay, just a sec. Just a sec. Let's just pause for a sec because, for one, I just want to point out, Hart did propose all kinds of refutations to the redshift, including the fact that quasars don't match the prediction, all can't be explained. That things that are much closer have much more redshift, and the list goes on and on and on and on. I do encourage you looking into that. Those reputations remain largely unrebutted, and he was excommunicated because he didn't follow the dogma. Okay, okay. So
communicated. Okay,
the inflaton thing, bro. It's like there's no such thing as an inflaton. This is a made up story, and it was proposed to explain things like the flatness problem and the horizon problem.
correct.
But
Well,
you know,
the inflationary model has been was developed to explain those problems. Yes,
right. So I just
What
want
are
because
those
I'm
problems?
trying to keep in mind that the audience doesn't know. Yeah. So like the flatness problem. Ironic, it comes into these circles, right? But like the horizon and flatness are two very ironic names. But so the flatness problem is basically like if I'm gonna put it in really simple terms, you can correct me or whatever you think I don't do justice or whatever. But like the idea is like if you throw a grenade and it explodes, right? Like logically, you're gonna think it explodes in all directions. And like this idea that there was a singularity, so like an infinitesimally small little point at the beginning of the universe, and then boom, it expands out. You would think that logic is going to span out in all directions, maybe evenly, even maybe, or like slightly oblate. And so then we have like these ideas of curvature of space, like curvature of the universe, right? Overall, that would happen. And you have a few different versions of that, right? Like basically convex, concave. And in their model, what's been realized is that the universe is surprisingly flat, right? Meaning like there isn't a lot of like overall curvature to it. And so they had to explain how could there be like a singularity and then the whole universe expands out from there, yet it's flat, right? Because why wouldn't it create curvature as it expanded out? So then they proposed this idea that there was like the inflationary idea, that basically inflation happened, which made it expand out horizontally so rapidly, right? That portion expanded out initially so much faster that it didn't create a curvature; it expanded out flat. Like you want to correct any of that?
You're close. So the horizon and flatness problems are more of a fine tuning argument, because let's take the flatness problem. Right now, with our observations, we believe that the geometry of space time over universal or cosmic time spatial scales is flat, meaning that omega equals 1. The issue that we are facing is that there is no a priori reason for why omega is 1. So the idea that, or the question that we have, or what the problem I suppose that it had, was, why is it 1? Why isn't it 2.5? Why isn't it 4? And so the inflationary model was created in order to answer the question of, this is how it got to be 1. This is how a big, or a something expanding universe, a rapidly expanding universe in the beginning, was able to ultimately become a flat space-time curvature. The horizon problem is about the fact that the universe is not wholly one temperature. Effectively, if you started off with a radiation field that was perfectly homogeneous from the Big Bang, whatever that happened to be, then it would, as the universe would expand, you would expect from thermodynamics that every part of the universe would ultimately equilibrize with every other part of the universe, and so the universe would stay effectively at the same temperature all the way around, everywhere through it. If that were the case, then you would ultimately not have any kind of structure within said universe. But what we can see is that with the cosmic microwave background, there are fluctuations, there are bits of the background that are not homogeneous. We can see structure within the background of the radiation. And so, in order for that to happen, or the current explanation for it, is that the universe started off with certain quantum fluctuations and then rapidly inflated, such that those fluctuations could not communicate with each other and basically equilibrate in temperature. Essentially, the coffee mug could not become room temperature in a way.
Yeah, and like really simple terms, bro. Like if you zoom all the way out, like you're looking at the whole universe, draw a circle in there. The circle will be pretty small, and that's like the horizon. And if you were to take the speed of light and apply it to say like a particle over the course of the entire universe's lifespan, which they claim is like 14 billion years, like
Thereabouts.
that part that what's up?
Thereabouts.
Yeah, was it like 14 and a half?
So 13.7
Okay, yeah,
billion.
13.7. So like say you take 13.7 billion years and then you use the speed of light, a particle, for example, could only travel so far, right? It could travel as far as you could get in 13.7 billion years going the speed of light. And so take that distance and use it as a radius, right? And then create a circle. And that circle would be ostensibly as far as any particle could travel in all directions. Yet that circle is very tiny compared to the whole universe. And the homogeneity of the energy and temperature in the universal model implies that have all been at the same place at one point. So there's a problem of like, how did that area that's homogeneous compared to this area way over there, you know? How are they somehow connected, but somehow, even though they didn't have enough time to get that far apart at the speed of light? That's how I understand it. It's just a fine tuning problem.
Yeah.
And so is the other one, right? Like the flattest problem is fine tune. And what and like if I think isn't the critical density number like so like I think it's like kilograms per cubed meter cubed. I don't know. I think so. It's like point 0.00000000000. You know, it's like I don't know, like
I've
20 zeros.
actually never looked at the unit of any of the omega terms, any of the critical density terms.
Yeah, okay, yeah. Yeah, I think it's kilograms per meter cube. I could be wrong, but it's like
Well, that's
it's
density.
like energy density. It's like that's what I meant when I say critical density, energy density. It's like mind-blowingly close to zero, right? And yeah, that's an issue. It's a fine tuning issue. So they then invent a particle that doesn't actually exist. Where have we heard this before? Right?
So
Just invent something that's never been observed, can't be
that
fully
is,
understood, can't be fully defined, but would have had to do some things, right? It's just like dark matter. We don't know what it is, can't define it, can't find it, but it has to have like these properties. And it had to be there. And now it no longer exists. They literally claim that, like, I mean, my understanding is that the inflationary models propose the idea of a inflation particle, an inflaton, that did exist at the beginning of the universe that allowed it to basically inflate out so quickly that it allowed it to be flat. But now it no longer exists.
that is one possibility. That is not the consensus. Right now, there is no general consensus as to actually what caused the inflation, only that the inflation happened. Because the observations, if you include inflation within the Big Bang model, then the observations of the stellar or of the universal structure, the large scale structure of the universe, actually hold to be true. Match observations. So the theory has a prediction of what the large scale structure should look like. If you include the inflationary period, then that expectation matches observation. This idea that we are absolutely claiming that there is an whatever it's called,
Inflaton.
it is not accurate.
What about a
Well,
Well, I
graviton
mean,
or any
how
other
could
of them?
inflation have happened if there wasn't some particle of inflation?
I'm not an inflationary cosmologist, so I couldn't answer that
Right.
question, but I could try to find out for you.
That would be great. That would be great. All I've ever heard is either the idea of particle or field, right? It always comes down to those things. And then there's still particles that are just localized excitation. So tomato, inflaton. But this is like, that's how Professor Parks would phrase it. And how I would phrase it is their model didn't match the observations and doesn't work
It does.
unless you add that in,
Well,
right? And it's just like dark matter
and
in
then
that
it
sense.
matches, and then it matches within the framework of the Big Bang cosmology.
Yeah, but don't you see how that's kind of that's like not cool, bro. Like you're saying it matches, but it matches now that you added the mathematical correction because it didn't match. This is just like dark matter, just like dark energy,
Ad
just like
hoc.
virtual photons. It would be like me saying, it would be me like bragging how people do this, bragging about how incredibly precise our quantum predictions of magnetism are, which they are, right? And excluding the fact that we had to come up with an idea called a virtual photon and plug it in because our particle physics model did not match the magnetic field or electricity, light, or static electricity. They plugged plugged the virtual photon in, right? That's Richard Feynman,
Yep.
who's quoted as saying, like, they're not the input or output of any experiment ever. Their existence is questionable at best. They're just a mathematical fix because our equations didn't work, right? And then to turn around after a few years and be like, our model perfectly matches observations. It's like, well, yeah, of course it does. Now that you saw the observations and how your model didn't work, and then you just put in some imaginary fix that doesn't actually exist, right? You see what I'm saying? We could always do that with any theory, right?
So, well, I would question that. It's not like anyone can come up with the inflationary model as a fix. That was that is not as simple as you seem to think that it was. It wasn't some kind of backwards engineering sort of idea. But to answer your question, is it cool if the scientific community said, all right, there's this inflationary period that has to be there in order for this model to work, and that did nothing else with it? That would not be cool. But we are still trying to figure out what actually physically caused the inflationary period of the Big Bang. We are actually trying to find what dark matter is. If we had just basically said there must be dark matter and just left it at that, then yeah, I would agree with you. That's just a fudge factor. That's just ad hoc. But because the observations that we're looking at indicate to us that there is a missing matter problem, then we invoke dark matter. But we are now trying to understand whether or not, or what dark matter is, and also whether or not dark matter actually exists, something that is frequently not spoken about in these conversations, is that there is active research that is attempting to explain dark matter as a deficiency within general relativity. There is something called MOND, which is Modified Newtonian Dynamics. That is an active field of research.
Yeah, I beat that like a drum, bro. But yeah, it's not brought up frequently in these conversations on the side defending the mainstream model usually. But I do agree. But you see, the problem is like okay, where's the time limit, right? Like the point is like, okay, 1933 is when we first observed that we had an issue with missing mass. It's been almost a century, and yes, now people are basically saying, okay, let's entertain these other ideas that don't require dark matter, because we've spent billions and billions of dollars and we can't find it, can't define it, we can't make it work. Okay, like this is the same thing with virtual photons. This is the same thing with inflationary theory, same thing with dark energy. And my point is, it's like, okay, yeah, it's cool that now people are just now starting to acknowledge and entertain the possibility that dark matter doesn't exist. But you do realize that if dark matter doesn't exist, then we have, in a way, wasted our, okay, I don't want to say wasted our time, and I know you're definitely going to take issue with that, but it's like we have unnecessarily remained stagnant for almost a century, because as soon as that observation was made, the scientifically minded approach would have been to say, whoa, our understanding of gravity may be completely wrong. Only 1% of the mass that's supposed to be there, according to our theory, is actually there. People should have immediately started proposing alternatives then, trying to figure out some other way it works then. But instead, it was approached very dogmatically. There must just be something we don't understand because relativity has to be true. And then we fast forward all the way to now, where, 7 or 8 years in these rooms, 7 or 8 years ago, 5 years ago in these rooms, I was being scolded for daring to suggest that dark matter may not exist. And we know dark matter exists. We just don't know exactly what it is yet. You know what I'm saying? Do you see my meta point here?
Couple things. One, it is shameful that you were lambasted or what have you. However, ultimately, that holds no that is not relevant to this discussion. How you were treated is not relevant as to whether or not dark matter exists, or as to whether or not the study of dark matter has been done so in a efficient or ethical way. Now, what's interesting is that you bring up that dark matter has been around since 1933 with Zwicky. The issue is, and Zwicky was actually ostracized, not because of his ideas, but because he was an asshole. And so people didn't like him, and so the idea of dark matter kind of sat on the bench. No one looked at it until Vera Rubin came. Vera Rubin came in 1970 in the 1970s and had very clear evidence that yes, there is in fact a missing matter problem. So she found that the Milky Way galaxy was rotating too fast in its extremities, and then she was aware of Zwicky's observations in the 30s, and that was two independent systems demonstrating a common problem. Now, was it cool what they did to Zwicky? No. No, it isn't. Is it cool that Zwicky threatened to shoot one of his co-authors for not agreeing with him on a paper? No, that wasn't cool either. No one is saying that the scientific process is perfect. No one is expecting the scientific process to be efficient. You're talking about we have been stagnant for however long. What does that matter to the ultimate truth of things? Okay, because we haven't been able to figure out what dark matter is. If we can't figure out whether or not dark matter is a thing by next week, then dark matter is not a thing.
No,
I don't see the logic in that.
Sorry,
how do you not see the point, bro? Like, who cares what the dude did or didn't do? It's about the observation. Scientifically minded approach dictates that you address the evidence right then. You don't neglect it because you don't like him. And it wasn't just because people didn't like him. It's just an inconvenient discovery. And then you brought up Vera Rubin in the 70s. Yeah, it is an inconvenient discovery. Right, you would agree. So that was an inconvenient discovery. Like, if relativity,
no, I do not agree it was an inconvenient discovery.
Bro, I let you get your stuff off, bro. Okay, so like, just give me a couple seconds.
I only interrupted because you said that I would agree with something, which I don't. Go ahead.
I only asked if you agreed once you interrupted, but it's all good. So like, the point is that before relativity, that's a very inconvenient discovery, right? We looked at the Coma cluster. That's a cluster of galaxies. And then according to the size of the galaxies, there has to be a certain amount of gravitational field strength that's holding those galaxies in. So the gravity has to be so strong to keep those galaxies in a bundle, in a bunch, instead of them moving out away from each other in a cluster. I'm saying it just so everyone can. Okay,
that's actually not really what his observation was, but
he observed the Coma cluster and saw that it only had 1%.
What he observed was the velocities within the Coma cluster. And there is this theory known as this theorem known as the virial theorem, that if you have a number of free-moving gravitational bodies, that given enough time, it's going to come into some equalized, it's going to come into an equilibrium where that the kinetic energy of the system is going to equal 2 times the potential energy of the system. And the kinetic energy is tied to the amount of mass. So everyone expected the Coma cluster to be what's called virialized, to be in this equilibrium state. And you can derive a mass from that. And what Zwicky found was that based on the dynamics, based on the velocities of the galaxies involved, that the mass of that cluster was something like 800 times what it should have been if the system was actually balanced due to the virial theorem. So I'm sure, I don't know, but I'm sure there were discussions as to whether or not the system was in fact actually virialized, whether or not that condition was actually met. But I haven't really studied the history. I don't know of any of the papers around the 1930s.
Yeah. So you said I was wrong, anyway, but like I'm not wrong. I'm not wrong. I said I wasn't wrong. Like I just Googled it. I'll just read what it says. I'll read what it says, bro. Fritz Zwicky observed that galaxies in the Coma cluster were moving too fast to be held together by the gravity of the visible matter alone. He calculated the cluster's total mass by estimating the mass of all the visible galaxies and compared it to the mass required to keep the galaxies from falling apart based on their high velocities. His calculations show that the visible matter provided only about 1% of the gravitational pull needed, suggesting the presence of a huge amount of unseen missing mass, now coined dark matter.
What I object to that, and I object to that, whoever wrote that, is it's not like the Coma cluster is going to fly itself apart. It simply has to do with how fast the galaxies are moving because of the presence of mass. The gravitational effect is proportional to mass, and that is proportional to force. The more mass you have, the larger the force. Or I'm going to use force. I know it's a triggering word, but just for simplicity's sake, the the force of attraction between various objects. If you include, if you make those masses bigger, then you have larger forces. So I'm quibbling over the idea that if the mass wasn't there, the coma cluster would fall apart. That's not actually what would have happened.
So wait, you're saying that you're saying that there isn't gravitational pull needed to keep the galaxies from separating?
No, that's not what I'm saying, is that there is sufficient enough mass to keep it as a coherent cluster. The problem comes in as to the speeds of the constituents of that cluster.
I mean, you're just
Effectively,
pulling hairs at this point.
Yeah, this is the pedantic, bro.
okay, I'm not getting my point across. The cluster, according to what you've read and what you've stated, is that the cluster, unless the mass was not there, unless this dark matter was not there, this cluster would fall apart. Correct?
Wait, sorry, say again?
You are claiming, from my understanding, that if the dark matter is not there, this cluster would fall apart.
Fall apart? I mean, like the galaxies would separate if there wasn't enough gravitational pull there.
And
No,
I am
obviously
telling you,
your
and I'm
paradigm
telling
doesn't
you that
say
is not the case.
Okay, so you're saying that there isn't. Okay, then why is more mass needed?
Well, mass is needed because the galaxies are moving too fast. That's
Okay.
ultimately what pretty much all dark matter arguments are based on. Is you are
Moving
looking
too
at
fast,
something that is
meaning what?
moving too quickly for the amount of mass that is present.
Okay, and so too fast meaning what? Like specifically, is moving too fast? Why? Like too fast for what? Like what does the mass do to fix the problem? Right? Like
So,
explain what the issue is in terms of like the relationship between the speed and the mass.
so
Does that make sense?
if you have more mass
Mhm.
and something is being affected by gravity, then more mass is going to produce a larger acceleration on another mass, which means it's going to have a larger velocity. So
Okay.
if you're looking at something that is moving at a set speed, then you can determine the mass of the thing that's effectively causing it to move at that rate. That's why it's called the dynamical mass. And as I was saying before, there is this expectation that if you have an n-body number, a collection of masses that are all gravitationally bound, that over a sufficient amount of time, the system is going to come into equilibrium such that the kinetic energy of the system is equal to 2 times the potential energy of that system. It's called the virial theorem. That expectation gives you what is that theorem. If the system does come into equilibrium in the way that we expect, then that will give you a velocity. That is the expected velocity of these galaxies. What Zwicky found was that the galaxies were moving around a common center of mass far quicker than the virial theorem would predicted, meaning that there had to be more mass within that cloud,
Right.
prompting larger gravity, prompting a larger velocity.
Okay, so the galaxies are moving around some type of quote unquote cluster of mass. Okay, if that cluster of mass was only 1% the size that it's supposed to be, what would happen to the galaxies? They wouldn't be clustered
So,
up moving around the same place.
yes,
So
they would be.
So
As
gravity's
I
not a
stated,
sufficient explanation.
so gravity's not causing them to move around the
no
central mass?
gravity. So, what is the current understanding of GR is that there is insufficient mass to explain the velocities of this cluster.
Okay.
Hence why it's
Yes.
the missing mass problem.
That's what he said
Yes.
the whole time.
No,
Yes, that's true, but
I am
they
going
would
to go
fly
to.
apart.
They will not fly apart. They
Okay, they're
are
going to magically stay
gravitationally bound.
there.
Yes, they
They're
would stay there.
gravitationally bound because and is gravity proportionate to mass?
So, with the virial theorem, again, we expected this cloud we see that this cloud is gravitationally bound, and we expected the velocity to be at a certain value. What we found is that the velocity is actually higher than that.
Okay, dude, you're just repeating yourself.
So if anything, the galaxy should be tearing itself apart because of the velocity that it has. And it's not.
Okay. So, I mean,
But the missing mass, the dark matter, again, it almost is a pedantic question or issue in that you are stating that without the mass, the galaxy would fall apart. That is not the case. That is
I didn't say
not
the
what the dark
galaxy
matter
would fall
problem
apart. I said the
or cluster.
galaxies. Yeah, the galaxies would move out away from each other because the gravity
They
isn't
would.
holding them together.
They would
Okay.
not.
I'll just cite my stuff, bro. So
Okay.
I'm
just curious though, Witsit, why are you arguing about like these are like the limits of our knowledge about
oh, thanks
we're
for the
talking about.
valuable input. Thank you. Okay.
But no. I mean, but we can't even agree on the basic thing about the shape of the Earth and
This
the
is
fact
what
that
they
we're in a
always. This is what they
heliocentric
always
solar
do.
system.
Don't
And you're
divert the
talking.
conversation. We're
So
trying
it's supposed to be a
address the part.
one-on-one, and then you jump in with that.
Okay,
Not
I'm
even
sorry.
something valuable at all.
I
Bro, what
apologize
does
too.
that help, bro?
But I apologize too. I jumped in. My bad, Professor
At
Parks.
least the interjection should be relevant. Like,
Yeah,
okay.
Okay.
But this is the thing, bro. This is the thing. Okay. Because we got all the way down in the hole there. I mean, you took contention was saying I wasn't quite right, whatever. Okay. I dropped some links. You know, I try to make things digestible for people that aren't familiar with all this. Because I got some feedback that one of our conversations was like giving over a lot of like common knowledge, right? That we had like in common. Or whatever. So, but either way, so like, okay, fast forward because you're like maybe he was a jerk, whatever. They ignored it. You're like, what's it matter? Like if we were stagnant, whatever, who cares? Like it's not like we have to do it by next week. That's kind of my whole point. What do you mean? What does it matter? Like, what does it matter if because of some type of philosophical bias, some type of like preferred position, some type of devotion to like the resources, time and resources and careers devoted to a certain paradigm, a certain understanding or assumption, the actual progression of figuring out what's going on is delayed significantly. Why does that matter? Why does that not matter? That's insane. Like, and you said something like 1970s Vera Rubin, right? But you know that was actually first observed in 55. So that just further makes my point. Like the issue with galaxy rotational speeds requiring dark matter was originally observed in 1955. So like again, it's like, almost 2 decades before it's even like really given the acknowledgement, like, okay, this is an issue that needs to be addressed. 70s, I mean, that's 50 years ago. That's half a century ago, right? Even the 70s. My point is like, this is a super slow process that has been super inefficient. And the people that were trying to say, yo, maybe relativity is fundamentally wrong, they're not given airtime. It's like rejected. And there's a guy, but now, like you said, tons of people are putting out modified Newtonian dynamic ideas that are basically saying relativity is wrong, and there is no dark matter. We don't actually need dark matter because billions and billions of dollars have been invested into trying to find it, and no one can, right? And there's a guy, and I'll throw it back to you, but there's this guy who has proposed a modified Newtonian dynamics theory. He's like an astrophysics professor in Australia. I forgot his name, and he's explaining. He's like, dude, not only is it possible that dark matter doesn't exist? Like, this is what he said. It's been disproven to sigma 5 confidence. And he gives an example of like these galaxies that were merging, and the amount of dark matter that was required to be in both of them, according to relativity, would have caused them to slow down significantly as they began to merge. But what we observed instead was that they didn't slow down at all, and even seemed to slightly speed up. And it would use the analogy of dropping like a marble in air or an empty jar or water and then honey. And it should have dropped like it went in honey, but it didn't. So my point is just to say the point he made and why I brought him up is he's like, the issue is all the funding in our field, like the large amount of the funding goes to dark matter. Like if you want to get a grant, say that you have some new innovative way that you think you're going to find dark matter. But if you're trying for the last couple decades, if you've been trying to challenge that notion, good luck trying to get funding. And he said this is extremely detrimental to science. Science should not be limited to biased funding like that, because what it does is cause tons of people to just pretend they're looking into something. The same thing with like climate change, right? Like you get funding if you confirm the idea that climate change is real. You'll get funding to go find proof of it. So can you acknowledge, at least on that, in that sense, that that's totally detrimental to us actually like progressing and figuring out what's going on?
I already have. I
Okay.
put out a video in response to Sabina Hassenpfeffer making the argument that you are making now, that effectively high energy physics is entirely financially motivated. It is no longer motivated by science. What I said in that video is she has a point, but she's taking it too far. And I would
Gotcha.
say that same thing with whoever the scientist is that they have a point. Now, I don't know how far they take it, but they do have a point. And do I think it's wrong? Yes. Do I think that our current system of funding is stuck so that we are putting too much revenue, too much of our money into the idea of a particle nature of dark matter? Yes, I do, because it has been 20 years where we have had the technology to really start exploring the phase space, or basically the energies, the masses of what these dark matter particles would have to be. I think personally that it is now time to redouble our efforts to look into whether or not relativity is inadequate. I have also said multiple times to my hundreds of students that I do not believe GR is the ultimate final word on gravity because of this conflict that it has with quantum mechanics. Something has got to give. So
It's
we
respectable,
don't know
brother.
what the truth is, but I'm hoping that we're going to get there, and I'm hoping we're going to get there within my lifespan, because I would absolutely love to witness a paradigm, or a what does he call it? Basically, a paradigm crisis. Thomas Kuhn has a particular word for it, but
Paracausal shift?
basically a scientific revolution.
Yeah, like a paradigm shift is what we need.
Yes.
And
So I want to be able to see that. And so, yes, do I agree that we are focused way too much on a particle nature of dark matter? Absolutely. But I'm not going to just throw out everything associated with that and say that everything that relativity predicts, that relativity is completely wrong and it cannot be used, and so the universe is therefore not expanding, and all of
yeah.
that.
Well, it's kind of
Nonsense.
like a false dilemma, right? Like these are very like terms being thrown around very lazily, right? Like it's like everything relativity is wrong. Like relativity incorporated a lot of like proven aspects of physics. You know what I'm saying? Like it's built off Maxwell's equations initially, right? Like
I'm
um
motivated by it, but yeah.
yeah, and like largely incorporated slight variations. So I'm just saying, like, no, I certainly don't suggest we throw away everything. Incorporated relativity has tons of things we know to exist. And then
Exactly.
upon the pursuits of like confirming that, we've seen that there is some truth to certain types of phenomena that I'm sure you would classify as some type of verification or something, but I think they are gross misinterpretations and they're typically cherry picked. But not to get through all of that, I guess like my point is like, isn't it interesting that there's a group of us that have adopted an autodidactic approach, would be labeled intellectually dissident, and have been saying unequivocally that we know dark matter doesn't exist, dark energy doesn't exist, that relativity is wrong, and here are the falsifications of it, and here's how they cooked the books from the beginning. Here are the implications. If you don't have a relativistic interpretation of MMX, we need to just rip the band-aid off and face it for what it is. Yeah, it has drastic paradigm shifting implications. I don't think that you're wanting that big of a paradigm shift though, right? Because it just obviously it means the Earth's not moving, and it means that we're detecting an ether drift or whatever. And I'm just saying, I think it's
So
funny. I find it interesting that if I were to go back in time and in 1886, as a geocentrist, make my prediction of what we're going to see, I would have been correct. And if I had been alive in 1915 or the 1924 and made my prediction about what was going to be seen with Edwin Hubble, I would have been correct as a geocentrist. And the heliocentric prediction would have been wrong in both of those scenarios. And if we fast forward up to now and we make our predictions about what's going to be seen when it comes to like cosmological observations and how they don't match relativity, we would have been correct. Same thing with the quantum scale, that we're going to find evidence of an ether. And what do you know? Quantum foam, vacuum energy, Casimir effect, the list goes on and on. So it's just interesting that we can just continually get rejected, that our position can continually get neglected, although it is consistently making the correct prediction. Yet the other side can just throw mathematical band-aids on there for a century and somehow it still holds like the supreme position. It just, like, to me, frankly, it's like laughable.
Okay. So if I'm hearing you correctly, you were telling me that there is a geocentric model that incorporates aether wind that can accurately and correctly explain things like the Michelson-Morley experiment, can explain things like the Big Bang, but like what we see with the evidence, like the cosmic microwave background, the redshifts that we see, everything that the relativity and the and the Big Bang theory currently explain fairly well. You're telling me that there is a geocentric model out there that incorporates aether wind that can do a better job, and it is simply being censored.
Well, I mean, it's just being neglected because it's considered not even a possibility within the dogma of modern scientism. And I would actually, it's not just like it can explain everything. It's like a blowout. It's not even close. Like that model is significantly better.
So, in order for it to be significantly better, I would need to see consistent results, actual mathematical experiments that were, or not mathematical experiments, sets of observations, experiments that were done from independent research groups that all have that all show the same thing. So, if you were going to make the claim that there is a geocentric model out there that in fact blows relativity away, that actually explains things better, then I really, really would love to see it.
Yeah. Hey, and I want to address that specifically.
Okay.
I just want to read this quote because I went and found it, because the idea of the CMB, like the most remarkable confirmation of a prediction of the Big Bang model ever or whatever. This is the European Space Agency, the Planck probe. This is the actual European Space Agency, the one that did it, right?
Yes.
This is a quote. It says, "One of the most surprising findings is that the fluctuations in the cosmic microwave radiation temperatures at large angular scales do not match those predicted by the standard Big Bang model." So
I would have to look at. I would have to look at that. I would like you to Google the 2.7 Kelvin blackbody curve. That's what I'm talking about in terms of matching. I would need to look into what the Planck people are saying.
okay, I'll look into this at a later time. And another quote. This is from the astrophysicist Glenn Starkman, Craig Copey, Dragan Huderer, and Dominique Schwartz. Okay, which is like a team studying CMB. Looking into this anomaly more deeply, we will find that it remains robust throughout all 7 years of published WMAP data, and which is CMB, right? And furthermore, that it is very difficult to explain within the context of the canonical inflationary lambda cold dark matter of cosmology, quote unquote, the Big Bang. The observations disagree markedly with the predictions of this theory. So, I will look into what you're saying, but I will also send you these guys' paper. I'll read one more. Astrophysicist Ashok Singhal. The apparent alignment in the cosmic microwave background in one particular direction through space is called, quote unquote, evil because it undermines our ideas about the standard cosmological model. The Copernican principle seems to be in jeopardy. And I brought that up just because this idea that there's like no one in these fields at all that have even like tipped their hat towards geocentrism simply isn't true. I mean, even people that don't publicly proclaim that position have made it clear in their academic writings that it is more viable than commonly recognized.
So I would need to see evidence of that. So saying that the axis of evil exists does not equate to geocentrism. And if you look into the axis of evil more, the axis of evil problem has been solved because all of the data
allegedly.
has actually been okay. All of the
Yeah.
data has
Was
actually been
misinterpreted
analyzed.
wrong improperly.
Was not misinterpreted. They didn't analyze the entire data set, and so the analysis that they did was biased.
Gotcha. I mean, even though this was a
So,
heliocentrist, and if
so
I've watched
again,
his
I'm going to bring
interview,
it back to you are telling me that there is a
how was it
geocentric.
biased?
You are telling me that there is a geocentric model.
Yeah.
How does it explain the large temperature differential differences in the Planck data?
Gotcha. I just want to say one more thing because, I want to read this quote because, first of all, like the part of that quote that was about geocentrism was the Copernican principle is in danger, right? This is astrophysicist Jonathan Katz. All of these are hostile witnesses. No longer could astronomers hope that the Copernican dilemma would disappear with improved data. The data was in hand and their implication inescapable. We are at the center of a spherically symmetric distribution of gamma ray burst sources, and this distribution has an outer edge. Okay, so and again, it directly addresses the Copernican dilemma or principle, but okay, so this is the alternative position, right? You have geocentrism, Earth in the center. Okay, so for one, that's going to mean that the interpretation of redshift has to be different, right? It is not accelerative expansion, and so you would say,
So
all right, obviously,
what is the geocentric model state?
yeah,
The
just a
one
second, I
that
got you.
blows away relativity. What does it
Yeah, I
state?
got you. I got you a second. And then because the reason I want to explain why I said it's a blowout, one of the biggest parts that would be a blowout is if there's an accelerative expansion, it would have the implication that the universe is much more dense, much more local, finite, and much younger, and quote unquote, especially young to quote Edwin Hubble, right? And then the point I'm making here is if you have like a much more dense universe that's electric, a geocentric electric universe, if these effects that we're seeing in the sky, like these galaxy clusters, galaxy rotational speeds, like these orbital motions, like all these different motions, certainly like galactic motions, if it's say electric in nature or magnetic in nature, then it could easily be applied to the phenomena. Whereas the gravitational interpretation or assumption is limited to proportionate mass, say a magnetic interpretation is not, right? Because
So,
you can have two sizes or two magnets that are identical in size, and one could be 1,000 times stronger than the other. So you could simply look at the coma cluster and say, okay, look, you could vary the field strength, say clearly this has a much stronger magnetic field, right? It's not limited to proportionate mass. That would eliminate the entire discrepancy of how like 83% of all the matter in the universe has to be dark, et cetera, et cetera. Can you at least acknowledge that idea?
done.
You might dispute that it's legit, and you would say you need evidence for it, and you need it to be explained, all this. But can you acknowledge that causal mechanism, say magnetism, as opposed to gravity, due to the fact it isn't limited to proportionate mass, thus wouldn't have the issue of missing mass, would be significantly more viable in that aspect alone.
Has it been done?
What's up?
Has it been done?
Has
As
If
far as I
you're
know,
telling me
no.
that the cosmological model or the geocentric model blows away relativity, I'm a practical guy. I want to see numbers, predictions matching, or I want to see observations matching specific expectation.
I'm asking you a very practical question, right? Which is like if the gravity model is based on proportionate mass and there are huge discrepancies when we look on, say, the galactic scale, then a magnetism model would not have that problem because it isn't limited to proportionate mass, meaning whatever amount of mass is there could still give you the field strength needed, right? That's being attributed to gravity. So don't you agree that in that aspect alone, it would be more viable? Meaning, if you removed the limitation of proportionate mass, any model that could sufficiently do that would be way more viable, right?
So the problem that you have with that is if you're asserting that magnetism is the force instead of gravity, then we would actually have to be able to observe extremely large magnetic fields in the coma cluster. We don't.
What do you mean by observe them?
Actually measure the
Magnetism,
strength of magnetic fields within the coma cluster.
measure them, right? Like
Yes.
what is being misinterpreted as gravitational fields would be magnetic fields. Like
No, we can actually measure the magnetic field of a star. We can measure the magnetic field of ISM. We know what the magnetic fields are in the galaxy. We can measure them.
Allegedly,
Okay.
in your paradigm,
Okay, so
allegedly.
now you are just going to deny that these measurements are actually measurements of magnetic field.
No. Well, specifically, what I'm going to deny is your presupposed framework, right? So, the ICM, right? So the interstellar medium, is claimed to be like a gas. It's extremely tenuous, predominantly made up of gas. That's way more thin, less dense than that gas here, and it does have electrical and magnetic properties. And they claim that they're very weak. All that, I get that, but like you also are assuming that the primary force, like causal, like force that's not a force but can be thought of like a force, the causal mechanism of the motion observed, for example, is gravity. And I'm saying that's false, bro. And I disagree with your medium assumption as well. So if I'm going to go out there and if I'm going to look at the sky, and I'm going to assume that it's a near perfect vacuum, right? There's only a few hydrogen atoms per cubic meter. Then I'm going to run all of the data through that assumption. I reject that assumption, and so I'm rejecting your denotation of magnetism. I guess just maybe you can correct me on this. I'm open. I'm open to being wrong on this right here. I just want to know. Am I tripping here? If we have if we say we have a lot of mass, right, and you're saying we don't really see it, but it has to be there, it's dark matter, whatever. You have galaxies moving around it, or you see a galaxy and you see it rotating, right, and it's rotating too fast. Do you agree that if what you're interpreting as a gravitational field, right, that the net effect in terms of the motion observed is basically synonymous to a magnetic field, the motion observed?
Again, if there was a magnetic field that could produce the same amount of acceleration that GR could, well, that we observe, then we would see the magnetic field. We could actually measure it. And actually, I don't know about the coma cluster, but we have measured magnetic fields around galaxies, and they are in no way strong enough to do what you are suggesting them or needing them to do. And it has nothing to do with a paradigm of gravity. Gravity has actually nothing to do with magnetic field strength and measuring magnetic field strength. So I don't know why you're equating the two. Just the fact that we are not just coming up with this model of, we think the interstellar medium is yada yada gas and dust, and so therefore we have to force these observations, I guess, into that paradigm. That's not how science works. We understand the ISM because of the observations that we made.
Okay. I am interested in talking about that with you. I just want to make it clear, right, that if I see a galaxy and it's rotating and it's going too fast, and in your paradigm, that the primary cause is gravity, if I were to take out that presupposition and replace it with magnetism, if there were a magnetic field there, it would cause the exact same motion observed. There would be a vortex.
To measure that field, which we don't.
But do you agree with that, though, that it would cause the exact motion that's observed?
If you were able to create an attractive field of the same magnitude that would produce the effects that we see. Basically, if you could produce an attractive central force field that could make the galaxy or the stars move at that speed, then yes, that would be a viable option. What I'm telling you is magnetism isn't the answer, because in order for a field a magnetic field to accelerate things at those rates, it's going to have to be an extremely powerful magnetic field, a field large enough that we could easily measure it, and we don't. The observations do not support that theory.
Okay, at least we did get there. That
What's the
yes,
compass
right.
then?
I just want to make sure everyone understands it, right? Like if you have a magnet, it's an quote unquote attractive force
Can be.
relative to the center of that magnet. And so it would cause things to move around it, right? Or be pulled in towards it, right? Like it would. So the motions that we observe, say with galaxy rotational speeds, I mean, galaxies look identical to a magnet under a ferrocell. Identical.
Which
And
galaxies? Are you talking about spirals? Are you talking about ellipticals? Are you talking about regular galaxies?
a spiral
Because all
galaxy, for
galaxies
example.
do not look
Like a
identical.
spiral galaxy.
A spiral
Then
galaxy.
how do you explain elliptical galaxies?
Different types of fields could be electromagnetic. The issue I always run into when I start proposing this alternative is it's like the field of cosmology, the sky is so vast for so many observations that the expectation that like on a whim, instantaneously I should be able to explain any specific one would be wild, right? Like that's like insane. We've had decades of hundreds of thousands of people probably and billions of dollars. I'm not trying to run away from your question. I'm just making a very obvious observation, right? That like
You have also
even
you're
you
cutting
couldn't.
in and out.
you have also made the claim that there exists a geocentric model that incorporates aether wind that explains relative things in the universe far better than relativity. So
Yes,
if you're
I'm
going to make
close.
that claim, then I don't think it's unreasonable for you to explain to me, at least superficially, how elliptical galaxies exist.
Okay, just to clarify, like I made a very specific point as to why it wasn't engaged with that, like an electrical universe that's invoking like electrical causes or a magnetic field as a cause would give you the exact same motions observed, the exact same phenomena observed, right? Celestial motion observed, right? Obviously, you would just, depending on the field strength, depending on the type of magnetic field, which there are many different types of magnetic fields, this is obviously going to be the answer to your question about the types of galaxies. And that because it isn't limited to proportionate mass, it blows relativity out of the water in terms of viability. Because in your paradigm, when you look up at the sky, you are constricted, right? Restricted to however much visible mass you see. So it's like your hands are tied, which is
Why
more
does it have
complex.
to
Wouldn't
be?
you want to be freed up? Don't you want to be freed up where you can actually like have viable explanations instead of just being like there must be something magical there that we don't understand?
So
You're breaking up
honestly,
a bit, by the way. Witsit.
what you're suggesting to me is
I'm gonna
magical.
back up.
What you're
Yeah,
suggesting to me is magical in the sense that
He backed out real quick, Professor Parks. His connection was a little bad. Okay, he's back.
Okay, sorry.
So
Is that better? Better? Am I good?
You seem to be cutting in and out a little bit, like you're clipping.
Here, just like
turn off your Wi-Fi or something if you're far away from it or something.
okay. Is this better?
I think so.
Dude, what is going on? Am I cutting in and out?
It's way worse.
No, it's
Now
choppy,
you're
dude.
roboting. Yeah, now you're roboting.
I'm gonna have to shut Discord down. Right back.
Yeah. Real quick, Professor Parks, by the way.
Yeah.
Remember what you were saying earlier about you would love to see a grand unified theory, right, in your lifetime, essentially. You didn't say grand unified theory, but
yeah,
you get my point.
Yes.
Have you ever thought about the implications that this grand unified theory and the idea of an ether or an all-encompassing medium that's tenuous like the ether, right, has already been utilized but has been occulted by the military for military purposes?
Well, like I said, I am pragmatic. You have to show me evidence for me to really get behind something. So,
Okay.
is
But
it
I'm just saying,
possible?
keep that
Is
in
it
the
is it
possibility.
possible? Sure. Yeah.
Okay.
As a scientist, I have to be open minded, and so
All right, cool.
yes, I will give you that. Potentially, maybe the military does have knowledge that we don't know about, but I don't have any evidence of that.
For sure. Go ahead. What's it? My bad. I just wanted
All
to
right,
ask
bet.
a little side question.
Check. Better than veterans. Don't want to let them in. Ain't got to, but let them in. Food is your medicine. Don't teach you that's like teaching you medicine. You can hear me?
Yeah.
Can you do it one more time, but like without the rap? No, I'm just kidding. Go ahead.
Yeah, you're good.
You're good, bro.
So,
Food is your medicine. Okay.
to get back to it, you're talking about magical thinking. To me, when you suggest that these motions can be described or by a magnetic field, to me that's magical thinking. Because again, I know that there's mass there. We can see the mass there. We can detect the mass there. It's not as much as we would think it would be, but when it comes to the magnetic field, we don't detect a sizable magnetic field in any way. So, in order for your idea to work, you would also have to explain to me how a magnetic field of that size could exist, but still remain undetectable with our current technology.
Okay. Okay. So for one, I did acknowledge a differentiation in mediums, right? And this is super important, but like I guess the most efficient way to go about this is for you keep like referencing alluding to this idea that you have some bulletproof method to know unequivocally and definitively the magnetism that is in space. So can you like explain? Because I don't know.
You're chopping
Can
up
you?
again, brother.
Oh my god! What? Okay. It doesn't make any sense for me to be chopping up. So am I still
That's
doing
me. I did it.
You can hear you though. It's just it is choppy.
It might be
this?
you, Beast. Is coming. Say something.
In a world
Yeah.
where
It
what?
doesn't seem
I
to be
literally
lag.
switched phones.
Is it me?
No, it's Witsit
No.
spot. It's the Wit spot.
Oh god.
Witsit asks, how do we definitively know the magnetism that's out there in space, essentially?
Yeah, I heard his question, but I just wanted to make sure that the connection issues were fine.
Yeah, so look, here's what I'm gonna log in on my other device and then restart my phone and see if it works. If not, I'll go to my PC. But I'll be able to hear you. So let me
Sure.
like stop.
I think you should disconnect from Wi-Fi if you hasn't already. And if you did, restart the router or whatever. By the way, Prof.Parks, while we're waiting for Witsit to come back, did you see the video I tagged you in? This guy's a super magnet
Oh, the
nerd.
magnet nerd. Yeah,
Yeah.
I haven't looked. Obviously, I haven't looked at it yet, but Omega Z. Okay.
Yeah, have you heard of him?
No, I haven't.
Dude, that guy is just a complete just lover of magnets, essentially. And he has so many different configurations that he tests out to see the different effects of the magnetic field, and then he uses like a polarized lens kind of thing to kind of see it so it's visual. And the one I tagged you in has a very similar spiral looking shape, just like a galaxy would. Not saying it's proof of anything or anything like that, but
So yeah, I hear you. I mean, but just because a Faro cell also looks like certain galaxies, to me, isn't causal proof.
I'm not saying it is. I'm just saying.
Yeah.
And the reason why gravity has to be considered, right? Is because that's the fundamental framework that you operate from. The idea that we have to measure the magnetic fields there, how is that even possible? What is the method to do that anyway? I remember you saying that you claim that we can measure magnetic fields of galaxies.
Yeah.
How is that even accomplished? I'm curious.
So the main way that we do that is something called Zeeman splitting. that in the presence of a significant magnetic field, atomic lines will actually split into hyperfine lines. And so you
You're talking about
have different.
spectroscopy?
Yes. Yes.
Okay.
Yeah. So to not get into the weeds, effectively, there is this observed effect called the Zeeman effect, where a spectral line is split into basically three. You have the core component, and then you have two side lines. Physics tells us from laboratory experiments that what we're observing in our spectrograph is the Zeeman effect. It is these are atoms that are contained within a magnetic field of certain strength, and based on the width of the two lines, you can determine how strong that particular field is. We do not see that in the interstellar medium. The measured strengths of magnetic fields in the interstellar medium is very weak. And I would need to verify, but I would imagine that some of those studies are done through looking at the Zeeman effect. Now, there may be other studies, there may be other techniques that I'm not aware of, but that's the main one that I'm aware of. Because my research, when I was doing research, is actually in magnetically active stars. And so that is the primary method by which we determine that. There are also some other secondary effects that secondary things that you would expect with if you had a high magnetic field. Those would be enhanced X-ray emission, for example. The reason for that is that you would have charged particles or free electrons within the gas. And if you have a strong magnetic field, that is going to rapidly accelerate those electrons or protons or what have you. And in doing so, that's going to emit a tremendous amount of X-rays, which again, we don't really see.
Okay. So it's all based off spectroscopy. Now, I don't want to devolve. I mean, you're basically looking with different, types of gas or whatever, right? Like different gas gives you different readings, right? Like something with blue is like hydrogen. I'm butchering it. Obviously, I'm paraphrasing, but like it's essentially you're looking at the cosmos through different ionized gases to give you different effects that you can observe. Essentially.
Roughly speaking, yeah. So spectroscopy is one of the observational techniques that we use. So if we're looking at magnetic fields, then I cannot think of a way that you could do it photometrically, which is photometry is the simple measurement of the brightness of things. So
I don't want to get on a side point, but I was curious about that. But thank you, appreciate it.
Yeah, no problem.
Witsit, are you back?
Yeah, can you hear me?
Ah, there we go. Solid.
Okay. I think I heard most of that. You're saying that in the presence of strong magnetic fields, we would see a break in like the atomic structure with spectroscopy, like spectroscopic observations.
Spectroscopic observations, we would see absorption lines, and I believe also emission lines. It could all work that way as well. In that, so real quick, absorption lines within a stellar spectrum are there because there are atoms that are in a certain atomic state that if you hit it with a very specific wavelength, it's going to absorb that light and then redirect it into another direction. So it's no longer coming at us. So that photon was originally coming at us. It hits that atom. The atom absorbs that atom and then very quickly re-emits it in some other direction. In the presence of a magnetic field, what happens is that what frequency or what wavelength that atom is sensitive to actually splits into three different levels. so that instead of a photon of a specific wavelength getting absorbed, you actually have photons of 3 specific wavelengths actually getting absorbed by that atom in that state. And so we see that in the spectrum as dark lines.
Okay. So there's so much here that I'm trying to think of the best way to not get so in the weeds. It's inescapable, I think. But
Okay.
so from my understanding, you can have a weak magnetic field, and you can still get very fast speeds in plasma, and there's like a name for it.
Okay.
Yeah,
Superluminal motion?
no, no, it's like named after a dude. Like,
Okay.
I don't know. I'll look it up. But
Right.
so that's one thing, right? Like,
Can you get masses the size of a galaxy to move? Can that method accelerate something that is enormous?
Oh, I'm not muted. Sorry.
yeah, well, yeah, why not? Like, we're talking about like, well, this is the thing.
Why not?
I'm saying that they fundamentally are magnetic fields. The galaxy is a magnetic field, and it's moving, and so obviously, like the distance and the size, right? And then the size is what's going to give you the speed, and then you're going to start invoking like what the force required to move said size is. I challenge all of the mainstream assumptions.
Okay.
Right. Like I don't believe them. And I think the major part that's presupposed is the medium. But like, so I will readily admit that in terms of like a replacement model, that would be where we're gonna diverge because you're gonna say, oh, well, then you're not even giving me a model unless you do that. And my issue with it, I've considered trying to do that, but it's like I would just be doing the very thing that I stand up against. I would have to just be making stuff up. I would literally have to just make up how far away things are, how fast things are moving based on how big they are. And it's like, I don't want to build an entire model and create a whole framework just all built off inaccurate presuppositions. The whole thing will be wrong. And so it's like, I
So,
mean, maybe it could be useful. I thought about just because people claim that it couldn't be done, it makes me want to do it. But like that's like an ego thing. It's what utilitarian purposes is actually going to serve. And like there are electric universe proponents that have done some stuff like that. So sometimes I throw the ball over to them just for like like what's it called? Like proof of
Conceptual?
concept.
Yeah.
Yeah, proof of concept. But like I guess there's so many things here with the situation. Like for example, what the average person thinks is that space is completely empty, basically, and that there's just like some stuff there. But then you talk about stuff like the interstellar medium, right? Where it's like all the space in between these stars actually does have a medium that's claimed to be very tenuous, and
well, in some places, yes.
well, like that, and then like the IGM, I think, seem to make up like an insanely high percentage, I thought, of the universe.
So I can't speak to the IGM because I've never studied the IGM. The ISM
IGM
has
again, real quick, just for the audience sake and my sake.
intergalactic medium.
Okay,
Yeah.
thank you.
The interstellar medium, or ISM, actually is not homogeneous. It's not the same everywhere. There are different phase states of the interstellar medium. You can have very hot, very tenuous gas. These are essentially remnants of supernova explosions. Or you can have exceedingly cold. We're talking like tens of so that supernova gas 100 or million Kelvin. Or you can have molecular gas where stars are forming. That gas is typically on the order of 10 to 20 Kelvin, and it is orders of magnitude denser than that hot, tenuous ISM. So it's improper to say that the ISM has a single property because there are different phases or different types of ISM, and some of them do get very dense.
Okay. There's obviously like a whole lot of things with spectroscopy, right? Like obviously localized spectroscopy in a lab is much different because it's a controlled environment. Obviously, we're looking out into the sky, and so there's whatever is in between us and whatever we're observing, and then there's tons of assumptions baked in to what we're observing, like fundamental
So,
presuppositions and characteristics. What's up?
so if we see a certain feature in our spectrograph, when we look in a controlled environment at a piece of gas, like a hydrogen gas, we have controlled it so that we are certain that the reading that we are getting on our spectrograph has a certain profile due to the fact that there's hydrogen gas at that temperature. We then point our telescope at a star and we see that exact same profile. How is it inappropriate to then make a claim that that is hydrogen gas at that temperature? We're not, the only assumption we're making is that the physics in the lab is the same as the physics in the star.
There's a go ahead. Witsit.
Again, there's like a vast area between us and that you need to account for, and I know that you guys claim to account for it, and you have like atmospheric corrections and all these things, thinking that you properly account for it, but like in really simple terms, and there's all kinds of gases even in our own atmo, and then we're gonna look up through it, right, and then look way further, and you're trying to read spectral lines. It's like, okay, I mean, you're gonna have to. It requires the accuracy of the final reading requires the accuracy of all of the corrections and accounting for whatever's in between us and them. And then oftentimes, like the fundamental, like the medium, so the ambient environment is presupposed. It's like I'm not hearing it. Like,
It's
and by the way,
it's
I
not
don't want
presupposed.
to.
So you haven't really answered my question. If we see a signature in our spectrograph that is identical to the signature that we see looking at a controlled hydrogen gas of a certain temperature and a certain density, how is it inappropriate not to say that the gas that we see in the star is hydrogen gas under those exact same conditions?
It's
Well, I did just
you just
address that.
explained it. Yeah,
Yeah,
it's
they're
logically fallacious because you're assuming
If
that there's
you,
like
a certain amount of things between you and what you're observing.
I'm assuming that the signature that I'm seeing in the star is identical to the signature that I have controlled in the lab, where there is no there is no intervening material.
okay, yeah. But basically the implication being that if it matches what we see in the lab, that there's no other way that it could match unless it is exactly what's seen in the lab. And I'm giving one of many ways, or maybe not many, but I'm giving a way that it absolutely could, because there's a ton of stuff between us and
And
that,
we
including
would
like
see it
hydrogen and ammo.
spectroscopy. We would
Yeah.
see it through spectroscopy. If there's a
Okay.
ton of stuff in there, why would we not detect it?
Wait, do you dispute that there's tons of gases in our atmosphere?
There are tons of gases in our atmosphere. They're called, and the spectral features are specifically called telluric lines, and we have studied them very well. We actually can use them as a source of comparison.
Right. So remember when I said, yeah, for example, there's stuff in the atmosphere, and I know that your field claims to make corrections for that and to account for that. But again, that's just yielding that those corrections are accurate. You said we've
And
studied it a lot. Like, okay, cool. Then what do you
and
know
then
about?
how are they not accurate?
I haven't studied it enough to give you a specific
Then why do you
refutation.
assume that they are not?
I
That they're
didn't.
not accurate?
I didn't. That's why when I initially responded, I simply acknowledged that as a real thing. And I have looked some into it where even those corrections are interpretations when it comes to astronomical spectroscopy. Like the corrections have evolved over time. So it isn't like it definitely wasn't some black and white thing. And when we first did astronomical spectroscopy, we easily were able to decipher what's in our atmosphere in our way and be like, oh, we can
So
easily
it
account for
was.
that. So, what's up?
I didn't say we did. Our
Right. Well,
as
that's my point.
technology improves,
Sure.
our ability to measure things improves. However,
Sure.
even with a crude spectrograph, you should be able to see the presence of all of the gases within the line of sight. That's kind of what spectroscopy is for.
Yeah, when you layer, what happens when you layer a ton of them, right?
Then we
Like it
see all of those
absolutely gets
lines.
complicated.
Then we see all of those lines superimposed on top of each other. If you
Right.
were to Google the solar spectrum, that thing is a mess. Those are lines on top of lines on top of lines.
Yeah, you're making my point stronger, right? So like
How am I
there,
making that point stronger?
because you're seeing there's all kinds of stuff between us and whatever we're observing, all the way out in quote unquote space, and we have all these spectral readings in between us and it, and so
We don't.
you're
No,
superimposing
don't.
them.
So no, you asked me how we would be able to tell that there is multiple species of atoms, multiple elements, and I told you that we would see a superposition of spectral features. But my main point is we don't see that in certain cases. Like when we look at the interstellar medium, we only see hydrogen, some oxygen, maybe some heavier elements. So how is our interpretation of that wrong? How is it that you're saying that there's potentially some sort of stuff that is between us that we're not accounting for? I'm asking, what is that stuff and how are we not accounting for it?
I'm actually not making any specific claim as to what is or isn't there.
Okay.
And to be honest, like even in my conclusion, my position is like you could in theory be right about what's there. Like it's not a problem for me actually, because like I expect to see like hydrogen, helium, and potentially some type of superfluid. And I would say that for sure, like the spectroscopic study of superfluid on Earth is very limited. And I'm not really making a claim here other than to say like it is not nearly, because what people do is they bring up like spectroscopy on Earth, which is very well understood, very precise, right? And then they just conflate that precision to like the astronomical application, which is not the case at all. And I'm not saying that you're doing that per se, but kind of. And like that's what's typically done. Like if I gave you a barrel and it had like 5 different elements in it and gases and stuff, and I put it like 500 yards away, do you think you could pop out a telescope, look in it, and like get exactly the distribution of elements in that barrel, right?
I have absolutely no idea. I
Right.
do not know how much resolution would be required in order to find out what those lines look like. So at that distance, what I
500
can tell
yards?
you is that we
That's
have
like
made.
nothing.
What I can say is that we have made high enough resolution observations of the interstellar medium, stars, um, galaxies. That's kind of a stretch, but stars in the interstellar medium. That if there was something there, we are fairly confident we would.
Do you dispute that there's tons of gases in our atmosphere?
There are tons of gases in our atmosphere. They're called, and the spectral features are specifically called telluric lines. And we have studied lines, and we have. Why would we not detect it?
Wait, do you dispute that there's tons of gases in our atmosphere?
There are tons of gases in our atmosphere. They're called telluric lines. The spectral features are specifically called telluric lines. What I can say is that we have made high enough resolution observations of the interstellar medium, stars, um, galaxies. That's kind of a stretch, but stars in the interstellar medium. That if there was something there, we are fairly confident we would have already seen it. And if we aren't seeing it, again, if you are refuting that what we are saying is what is there, then you need to come tell us what actually is there and how can we look for it? Why are we not seeing it?
Okay, brother, this is fundamentally incorrect, right? Like if you're making a claim about what is there, I don't need to replace the claim and tell you what is there before or your claim is true, right? Because imagine if it just in theory isn't knowable. Then that would be a terrible standard to use, because that would mean whoever makes the first claim is right. Right. And that's not how like truth
How is
works,
it
of course.
unknowable? How? So are you saying that there's something physically there that we cannot understand?
Oh, I said
No.
if it was unknowable, but what I'm saying is I did look into this some, right? And what I found
Yeah.
out is that like the resolution of things, like it's all limited on resolution because
Yes, effectively.
yes, that's like a huge thing, man. Like if I just asked you a hypothetical about something 500 yards away and we're talking about resolution, we're talking about in your paradigm, like trillions of miles away. And I obviously don't necessarily believe those numbers, but the point is that it's pretty far away and that there's obviously our Atmo, whatever, you know, and bro, my actual framework, my actual cosmological model has containment with layers and different densities of a fluid and of a fluid-like medium, and potentially something that acts something like a superfluid, right? Which would explain the lack of viscosity. But like, I tried to find like spectroscopy in terms of superfluid, and there's basically like really almost nothing. There's only some stuff I can find. Like, there's not like sufficient data on that, much less like at these vast distances. And then when you actually start looking out these great distances, the resolution, I just want the room to make sure that they actually know this because when I started figuring out exactly how limited this was, I was blown away because the confidence in which it's presented with is laughable to me. I mean,
Same.
or just I would just say misleading. Like astronomical observations are extremely limited when it comes to resolution, even of stars that are not considered to be that far away.
Also,
So
it shouldn't fly by your head, Professor Parks, that he says that when you are providing a positive claim, he's actually not liable to make a positive counterclaim or like a different claim. He can. Yeah. Okay.
But so sorry, I was. So can you quantify the lack of resolution of astronomical observations, and can you do so with the different instruments that we're using?
no, bro, of course not. Off the top of my head, I obviously couldn't do
Okay,
that.
so
Secondly,
you're
I don't
making a
even know.
claim that you,
No.
to be
No.
fair, know very little about.
Please, other people don't jump in. It makes it 1,000 times harder, bro. 1,000 times harder. So, no, I'm not saying that because I don't even know the specifics of an observation and the equipment, and I have to look into it. I'm talking
But
about
you
the field
do
of
know
astronomy
that
as
they
a
are
whole.
not
The field of
accurate.
astronomy as a whole, I didn't say that either. The field of astronomy as a whole, when I went and looked at it, I found out that the acceptable limit of resolution was way different than it is portrayed to like the layman. Okay. Now we're talking about stuff like galaxies, interstellar mediums from like vast distances, certainly in your paradigm. And I know that the greatest telescope on Earth still isn't giving you this super crispy, undeniable, indisputable resolution of spectral lines. That just isn't how it works. It's progressed over time and it's changed over time. And like look, I'm just gonna say because I know this to be true. So you agree that there have been some observations of astronomical spectroscopy that were later revised as we got better telescopes that got better resolution.
Yes.
Right. So that's my point. There is just an intrinsic relationship between accuracy and resolution, even in your own paradigm. Okay. So all I'm saying is it's not this cut and dry, like we know exactly what it is. And again, I'm not even saying that it's impossible that you were right or that that's something I reject, that I would refute any position that I hold. Right. This is why I also said that I know we're going to get in the weeds because like, you know, I'm not going to claim to be like an expert on everything spectroscopy. I would hope that you know more about it than me, Ashley. You know what I'm saying? Because that really isn't the point, though, bro. Like, I do remember looking into some of this, and like I even looked at it one time in terms of like how they supposedly decipher if we see magnetic fields. It's just super fuzzy for me. I remember that there are certain types of like turbulences, like there are certain phenomena that causes turbulences, and I forgot they're called. There's certain patterns of magnetic fields that get lost in basically the noise. And there's also like some phenomena of relative to polarization that can cause like a canceling out. And like in really simple terms, and again, I'm super rusty and only have limited understanding of this, but like basically there's so many there's so much that's going into the reading to the observation that it's very possible for things like magnetic phenomena to basically get buried in the readings. And so if we're talking about trying to look at like breaks in spectral lines and well, if there's only these breaks or these are how intact these spectral lines are, well, if it was a strong magnetic field, I would expect to see this. It is highly theoretical and speculative. And it's very difficult to sift through all of this data when you're accounting for things like plasma, electrical currents, eddy currents, magnetism, different types of magnetic fields, right? Like it's definitely not a super simple science. Even trying to map out the specific, like say, electrical properties of the ISM is admittedly like a very like open world, open field. Like we're just trying to figure stuff out the best that we can within your own paradigm. That's not easily
Yes.
done. It's not like they just looked up and they're like, boom, we know exactly what the ISM is. We know how much plasma is there. We know what ionization levels are there. Like, that's not the case, right? Like,
But
at
we
all.
have a pretty good idea. You seem to be presenting this as if we have no idea what we're talking about.
No, I think you do have some idea. I think that we're trying to figure it out the best that we can, and I just
Yep.
think that it's it's very limited. And like where we're at right now is like, if we look back in 100 years, we're gonna well, we're making caveman observations. Like, that's what I think. And maybe you could disagree or take. I'm not trying to be disrespectful or anything, but like just look at where we were, at time of Edwin Hubble. When Hubble made his observations, we were like, oh my gosh, we've advanced so much. Those are like laughably primitive at this point, or archaic,
Yeah.
right? Right.
But
That's what I'm saying. So,
but our observations now have never overturned anything that Hubble found.
well, yeah, because he just made like very basic observations.
Because that's all he could do with the
Right.
technology that he had.
And I'm saying that's all that you can do. That's all that you can do. But like,
Well,
even
yeah.
within what you've done, they have observed a lot of electric and magnetic phenomena in quote unquote space. We see tons of phenomena that's consistent with electric and magnetic phenomena. So then to
They
double
have.
back and
They
be like,
got-
you know exactly how like strong it can be. I don't buy that at all.
Okay. I don't know why you don't buy that. I'm not suggesting that we don't see magnetic fields or electric fields in space. Quite the opposite. We have seen these in space. What we have not seen are magnetic fields that are strong enough to do what you are needing them to do. Now, if you're suggesting that there is some kind of magnetic phenomenon that's out there where the magnetic field can be low in magnitude, yet still have the oomph or the force to move things around, then I would like to know more about it. Because as far as I know, that's not the case. The other thing is, yes, it is very complicated, but we do talk to each other, not as much as we should, but we do talk to each other. And so I'm fairly confident that if there was some magnetic theory out there, superfluids or whatever, somebody from them would have said, hey, you need to check this out and look at what these are the expectations that you would see given a superfluid and see if they match your observations. And as far as I'm aware, they haven't.
Okay. So
you also I just wanted to address one more point. Sorry. One more point. You have said that we present the spectral resolution to be far better than it actually is to the layperson. Can you give me an example of that?
Well, just the overall like I don't want to use some words, I guess. I don't really like, because you in particular, I don't have issue. I think you're pretty honest, but like the overall like confidence in which the field of astronomy and astronomical observations is portrayed to the layman, even in pop sci articles, certainly in a lot of these rooms, and trickled down from like basic like simplistic renditions of astronomy in school and stuff like that. People seem to think that we're throwing telescopes up and we're like really seeing what's going on. And, when I was reading like a Harvard paper, for example, about the acceptable resolution limit due to turbulence and stuff like that of just a basic observation of a star, they're I mean,
10 by 10 pixels.
Many arc second like error margin windows and like the pixel limits that really aren't impressive at all. So we're gonna throw like another layer on there and say, oh, we're gonna be able to resolve the elemental composition. I think we should be very transparent with the public that it's like we're basically cavemen, trying to we are like in the sense of like the universe. It's like we're basically like a child that ran out in the backyard, right? And then grabbed a little tube and put some glass in there and is trying to like look through the pool or something. Like we're not like, dude, we're not getting these super high definition, highly resolved, indisputable observations. Certainly whenever we're looking out further and further. Like even just stars are not that greatly resolved. We have like just the turbulence between us and the star in the atmosphere. It like the turbulence is a huge factor. And I don't know specifically, maybe you can answer that. Like, how does, say, turbulence affect spectroscopy readings? Because from my understanding, that's a big part of it, that the turbulence within the reading can cause like improper readings. And it can even cancel out some of the spectral line distribution and stuff like that, the turbulence specifically.
So I would need to know more specific as to the aims of this, but I can't answer your question. If by turbulence you mean gas motions, motion of gas particles in that collection of gas, what that's going to do is that's going to cause the spectral feature to broaden. Basically, it's going to the feature. If the gas were still, then the absorption feature would have a width of say a couple of nanometers. But because the gases are moving around so much, the spectral feature broadens out to say 10 or even 100 nanometers. That is problematic because if you have two spectral features, one from hydrogen and one from oxygen, and they just happen to be within, say, 5 nanometers of each other, if either one of them is turbulent, is significantly turbulent, to broaden it out to 100 nanometers, then you're going to have what we call a blended line. The absorption feature is going to be blended. So we are aware, the scientific community, the astronomical community is aware of these things. We know of ways to mitigate this blending, and we also are honest in the papers when we make claims like, okay, this is a blended line. To give you an example that I think is pertinent to this conversation, this part of the conversation, I want to state first off, I am not a fan of our current science communication. It does not do a good enough job to emphasize what we don't know. It makes a lot of claims that are misleading. So the example I'm going to give you is, you may have heard that we have found a biosignature around an exoplanet. That was getting some traction around. I looked at that and I said, okay, that's an extraordinary claim. Let me look at the paper and see what it says. And the paper is very speculative. The authors of the paper basically are saying we might have a detection of something that might be a biosignature. So basically, to me, the paper is interesting in that it is a kind of a hint of a gold coin at the bottom of an ocean or a bottom of a pond. Is that gold? I don't know, but it makes me want to find out. So with that paper, that makes me want to say, oh, I need to look at the system even with more precision, with greater rigor. But I would not say that there is a biosignature there. I would not have done what the scientific or what the science communication community has done, which is separate from the scientific community.
When you see a star and then you see a darkening of the star and then a lightening of the star, because exoplanet has passed through the light, there, as it gets to the edges of the star where it's illuminating the exoplanet, they can actually tell by the signature, by the spectroscopy, determine what atoms they're getting the signature from.
Dude, what are you doing? Why are you coming in a room with an actual PhD astronomer pretending to teach more efficiently about?
Can you let me finish it's unbelievable. You cannot even let me.
Well, we were supposed to be having a one-on-one back and forth, and you're acting like he said his thing, and I was going to respond, and now you're whatever, dude. Like, what are you doing?
Isn't that how they determine the atmosphere of the exoplanet?
All right, but Zanuck, it is a one-on-one, so
I didn't know it was one-on-one. I'm sorry,
a wild Zanuck enters.
It's like, why? Yeah, exactly. Like, why? Like, bro, because I really want to say something to you. I don't know if you ever heard of this. So, like, back in the day, like in the 60s or something like that, they actually replicated, and this was, I think, for the purposes of like astrophysics, like to better understand astrophysics. They did like experiments in the lab where they were replicating galaxies, right? And like just basic phenomena in the galaxies and stuff like that. And they this guy successfully replicated like a I don't know how many arms it had or whatever, but like a spiral galaxy using like plasma and magnetic fields.
Okay.
Have you ever heard of that?
No.
Okay, I'm gonna look it up right now. But like
I got it
that's
right
totally
here.
a real thing. Yeah, someone can help me look that up. It's totally a real thing. And then since then, this is like back in like the 60s or something. And since then, they've done it even more advanced. They use like lasers and magnetic fields and plasma. And we're like, I'm not gonna say perfectly, but like to an astonishing similarity, replicating galaxies and spiral galaxies, et cetera, and it's using plasma and it's using magnetism. And guess what? We like even in your own paradigm, they're acknowledging like an ISM, which is like gas that's ionized, which is a plasma. Plasma is ionized gas, right? And so we have all the conditions needed. And then this is the whole purpose of those type of tests in the first place, replicating the environment needed. What do you know that on the small scale, when you utilize magnetism magnetic fields and plasma, you start getting phenomena that looks identical to galaxies and their structures and their like their rings and their spirals and like the filaments. And I'm saying, hey man, yeah, guess what? Nature did the same thing on a much larger scale.
So when you say replicated a galaxy in some kind of magnetic cell, so they replicate. So that material is composed of primarily hydrogen, helium. There is a mixture of gas. There are mixtures of stars. There are mixtures of gas, dust. That's all in there.
Yep.
You can see dust from a galaxy.
Dust in a galaxy. Oh yeah.
I'm trying to find the exact one just for the sake of the
Hey,
conversation.
look, I've
Yeah.
already found something here. So, dang, dude, I could try to switch to my iPad here and share screen, but I'll drop this link. This is here. It's showing a photo sequence of Winston Bostick of Stevens Institute of Technology. Is that the same one you got?
I think so.
So it shows the evolution of a miniature 8-armed galaxy formed by the simultaneous discharge of 8 plasma guns. And if you look at the pictures, bro, it looks exactly like galaxies. It looks exactly like galaxies.
You think a grain of sand would float in there?
So, for one thing, just because they're calling it a galaxy,
but this is the one you're talking about.
okay.
Right there.
So, just because they are calling that a galaxy doesn't make it a galaxy. So, the only way that I know of to make a galaxy is to actually simulate one using a supercomputer. They are incredibly dynamic or incredibly complex structures. Yes, can you create spiral structure in things using magnetic fields? Sure. Does that mean that is what's actually generating the spiral structure within spiral galaxies? Not necessarily.
Of course, that would be fallacious.
Is it more viable than gravity? Thanks. Thank you.
Okay, of course, not going to say yes to that, bro. So please, can we just show? We can open up in a second, but okay, dude. My point is, I'm not saying because it can be replicated and it looks like galaxies, that's what's happening. I'm making the point, right? One of the initial questions was about well, how would you explain elliptical galaxies? Well, I'm sure you haven't done a ton of research into magnetism, and to be fair, magnetism is a very complex, nuanced subject that's admittedly not even well understood in mainstream modern academia, right? In terms of the true causal mechanism and stuff like that. And I already discussed the virtual photons. Throw all that aside. Using magnetic fields, which there are tons of different types of them, right? You have magnetohydrodynamics. You have different geometric expressions of magnetic fields. You have vortices and counter vortices within certain types of magnetic fields. You have all kinds of them. So, when it comes to the various motions and expressions, geometric expressions of galaxies, possibilities are endless when you got magnetism and you got plasma. And what I'm saying is dude, I mean, how much more obvious could it be? Yeah, the pictures perfectly match. I know one thing no one's doing in a lab, bending space-time. They're not bending and warping space-time and replicating galaxies in a lab, right? So we can use magnetism to do it. And there's a misconception here, right? That the magnetic fields have to be insanely strong to cause these things to happen, because that isn't the case. I know that, again, there's a phenomena that with even weak magnetic fields, it's a certain effect that was observed, and it was named after the guy that discovered it, where you can get really fast speeds in plasma due to the interaction of the magnetic field and the plasma itself that give you great speeds even with weak magnetic fields. And so these galaxy rotational speed issues that you guys have, I don't have that issue in my framework.
I just dropped a link in the chat.
So of what? You say that there are very strong motions, that it can create very fast velocities. Very fast velocities of what?
The plasma. And so what's happening is the plasma is taking shape relative to the magnetic field. It's being distributed relative to its densities and ionic properties based on its interaction with the magnetic field. And it's causing the plasma to move super fast, even though the magnetic field is weak. And so what we're seeing when we look into space is basically we're seeing a magnetic field, which, by the way, is invisible, right? And then just like how we use a ferrocell, what we do is we take 2 optical flats, really flat pieces of glass. I'm not sure if you're familiar with it. I think it's one of the best inventions in the 21st century. You have your optical flats. You're going to take some ferrofluid, and then there's some stuff like mousetrap fluid or something. It's just some other lubricant. You put that on the optical flat, and then lay the second piece on top of it. So basically sandwich it. And then you can super glue the outside, whatever. You can line it with LED lights. And then when you place that over a magnetic field, you're able to actually visualize the magnetic field in some of the most beautiful pictures you ever imagine, right? What you're actually seeing, of course, is the fluid that's distributed relative to the magnetic field, right? That force, and then the light is just creating these images based on the different density distribution of the fluid. So it's just lighting up the fluid itself, moving around because of the magnet. Well, and you should look those up. Ferrel cell images are incredible, and I think I just saw some in the chat. You maybe have seen them. I'm just saying that the same thing's happening in space, bro. I'm saying that like, there's a bunch, there's a medium there, and the magnetic fields are. Yeah.
But what I'm saying is, and actually, I spoke. A buddy of mine just got his PhD in physics, and he specializes in magnetism. And he basically told me
I know
that
you link me, bro.
Hmm?
You were supposed to link me.
I was gonna say that would be cool to talk to that guy too. You should bring him in
maybe,
here.
you could find his channel. Actually, he doesn't post on it anymore because he was a grad student when he was posting it, and then life. His channel is AB Physics.
AB
Okay.
Physics.
I want to. Remember when we
physics.
first did the in the field thing? And hey, yo, just for the record, was I a hospitable host?
Yes.
Okay. Okay. So,
Was I a hospitable guest?
Yes, indeed.
Okay.
But like, I had a few guests scheduled, and they ended up canceling after my first show. But it's all good. But I just remember you mentioned this guy then too, and I'm like, bro, I would freaking love to talk to that guy because I want to normalize conversations with. And by the way, I think that this is more of a meta point, right? But like, the best thing that you guys could do, quote unquote, as in people from within the academic establishment, is to overcome kind of this very poor communicative style that we've received, which has resulted in massive misinformation, and then basically deter people from even wanting to learn about it. Is to just like be more accessible and like engage with us, right? And you are one of the exceptions. Of course, you do that. But that's what we need, bro. Like, if I'm like so wrong about everything, or some of these distant ideas say we're a byproduct of the misinformation and the poor education system, like, okay, well then come talk with us. Like, be open to other ideas, be open to people that want to learn and want to hear about this stuff. So anyway, I know that's kind of like just a rant, but it's like a major issue I ran into. It's not like everyone's got all their nonsense they want to say. Of course they don't talk to you because you're so stupid. But it's like, well, that's not what people say in private. I'm just confused, and maybe you could shed some light on why. Is it like they feel like they have too much to lose? Is it participating in conversations like this could be risky for them, or like I guess I don't want to change the subject. I guess we can talk about it later. But if you can link me with that guy, even if it's private, I would greatly appreciate it. If not, I will reach out to him myself. But
I mean,
don't
I
always
can
have the
reach
great.
out to him. I can reach out to him. I think I did at one point, and I can say that he was not overly receptive to it. I can tell you this from my experience dealing with, shall we say, professional scientists, why they don't want to engage, and it's hubris, I guess, is they see it as a waste of time. They see that your claims, they believe that your claims are completely specious, completely false. They're out there, that they do not want to waste their time talking about it with you. And yes, they generally speaking, from in my experience, they have a negative view of your intelligence and your capability to learn.
You can change that, brother.
I don't know. I mean, I can talk to them and say that there are people who believe that the Earth is flat and geocentric that are worth speaking to, that will not waste your time, that are actually truthfully wanting to engage in these subjects. And to a small part, I have done that, but it doesn't really come up in my day-to-day work life. Although I do tell people that I engage with y'all quite a bit. So I mean, yeah, I can. Bottom line, I can do what I can, but I can't force these people to do it.
We can't put them to gunpoint, but it's all good. I will say, bro, I found what I was talking about. It's called, and I'm butchering the name, I'm sure, but Alvin, Alfven. I'll drop some sources.
Oh,
Alvin
Alvin
speeds.
waves. Alvin, okay.
So weak magnetic fields correlate with low Alvin speeds, which is the speed of a transverse magnetic wave propagating through a plasma. And they can go really fast, even though the magnetic field is weak. And what's so funny, bro? I looked this up, and then one of the publications that popped on the first page is interplanetary magnetic field. And it's relevant.
Alvin waves are one of the questions, that open questions in stellar structure is you have the coronal gas, which, again, we claim to have evidence that the coronal gas is about 1 million Kelvin.
Shout out, Graham.
The problem, when we recognize that this is a problem, is given how we understand stellar stars to work, how does that gas get so hot? What is it? What mechanism basically speeds that gas up so quickly? And one of the leading explanations is Alfvén waves. Actually, is that you have these magnetic pulsations that are coming off of the sun and are driving, basically forcing these electrons to move at very high rates of speed. So yeah, I have heard of Alfvén waves, but I haven't really looked into them too terribly much.
Okay, cool. Yeah. Yeah. I mean, and I only invoked it because it can be demonstrated that you can get like really fast speeds, though the magnetic field is weak. And like, bruh, this is, by the way, you're going to just keep discovering that you need that magnetic either phenomena is observed. This is, of course, my prediction from my framework, right? That observations are going to continually be made that are consistent with magnetic phenomena or require magnetic phenomena to sufficiently explain, right? This would obviously be the prediction of my framework. And like, dude, I saw a paper, I brought a paper up last night. And it's like the pop sci title is like Dead Star tricks astronomers into thinking that it's coming our way. I mean, I brought this up to you, and so they thought that this star was heading towards Earth or our solar system, quote unquote, because it was blue shifting. And then what they discovered over time was actually no, it's not heading towards us at all. It just has a really strong magnetic field.
Okay.
So just like, oh, so now we understand that like the phenomena of blue shift can be directly correlated to the magnetic field.
I was not aware of that. I wouldn't know how that would happen, unless if you're talking about unresolved Zeeman splitting, where the Zeeman splitting is. You're talking about. Well, I was talking about line broadening or the width of a line. If the Zeeman splitting is subtle, depending on the resolution of your spectrograph, it could actually be hidden. It actually can be hidden and blended into a single line. But the magnetic field has to be fairly weak for that, depending on the resolution of your instrument.
I mean, I'll quickly read the first part of this. Like, the remnant of a dead star predicted to cannonball through the outskirts of the solar system is going to do no such thing after all. On re-examination, a white dwarf star just 36 light years from Earth, named blah, 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 has turned out to be pretty normal. Its only claim to strangeness is its powerful magnetic field, according to a team of astronomers led by whatever observatory and planetarium in the UK. It's this magnetic field, the researchers say, that led scientists to misinterpret the trajectory of the star through the Milky Way galaxy. Blah blah blah. It goes on to explain that the cause of blue shift was a magnetic field, and it was misinterpreted as like heading in our direction. Yeah, I'll drop that.
Yeah, please do. I would love to read that.
That's just a pop sci article, but I'm sure it references something. Then I dropped the album away, but you're already familiar with that. Well, yeah, maybe not.
Sorry, I just want to make this little bitch. One of my problems with science communication is they don't always reference the paper, and it drives me fucking insane.
I got
what's
a paper for you.
Excuse me, Witsit, what's your explanation for how the 24-hour sun works in Antarctica?
We're not talking about that right now, bro.
I know, but is there a time that we can talk about it?
Yeah, maybe later,
okay. All right, I've actually found the paper that's talking about this, I think.
Okay,
the
cool. I dropped another
case of WD 0810353. Yeah, I looked at the article just enough so that I could actually get to the scientific paper because, as I've stated, I don't like science communication because they often sensationalize things and get things wrong. So I just want to get it from the horse's mouth. So, but yeah, I've got it.
Cool,
just for sorry, I just wanted to mention I'm collecting all the Bostic papers. I have all of them, and I'm going to link them for you guys. So, and I know you like papers, Professor Parks. So I got you. I got all the papers for you.
All right, so. I do want to actually change the subject if I could.
And I'm going to tag you in it, by the way. So I just want you to grab it.
All right.
Yep.
So
right there.
You were saying, let's see, let me download this report.
Yeah. Thank you, brother.
By the way, replicated galaxy clusters using plasma magnetic fields too in more modern times.
Okay. So you're talking about why is it that engagement of folks like myself with folks like yourself. I would say that you're talking about the fact that you have there have been bad actors who have belittled you, insulted you, all that sort of thing. Would you admit that there are also people on the flat Earth side who are also belligerent and who make it
of
difficult
course.
to
Yeah, for
engage
sure.
with?
Of
So,
course, of course. I mean, I was buried by them when I came back from Antarctica.
like one of the
I'm
reasons
only a
why.
6.
So one of the reasons why I have never liked Jaren is because he's an asshole. He was an asshole when he was a flat earther. He's an asshole now, and so I've never really engaged with him because of that. There have been certain Glober, I guess, creators that I have distanced myself from because one of them was always an asshole and the other one has turned into an asshole. So there are, and I have a video out on this. I did a video like a year or so ago asking for the toxicity level of this conversation to come down on both sides. I think these things can be discussed in a rational and calm way. I mean, obviously it might get a little heated, but there's no reason for name calling. There's no reason to personalize attacks. There's no reason to comment on someone's intelligence. You want to talk about the argument. You don't want to talk about the person. And so, yeah, I'm fully on board with that. And I can do what I can on my end, but I would hope that people on your end would also, that you would do what you could to kind of tone the temperature down.
When has there been name calling between Witsit and or Jeranism? Do you have specifics? Because they have not talked bad about one another at all.
I don't think you're understanding his point. Yeah, that's not what he was talking about. But I agree with you, Professor Parks, just for a side note. And I really appreciate the cordialness of this entire conversation comparatively to the last other ones that we've had. So thank you, by the way.
No problem. Yeah.
Can you reiterate your point then, Professor Parks? I thought you were talking about there was name calling between the two of them.
He was saying Jaren's an example of someone that's been pretty toxic historically from his perspective within the flat Earth community, and that people do it on both sides, and he can do his part to try to talk to people on kind of the quote-unquote globe side. I would hope that I would do the same to try to talk to people on the flat Earth side about lowering the overall toxicity in the conversation.
I got it. Thank you.
Yeah.
So, Jaren specifically, I was just generally saying that Jaren has been toxic to when he was a flat earther, and he's toxic now when he's talking to flat earthers.
He didn't just suddenly become your best friend overnight because he agrees with you now?
No. And I have made myself rather vocal about why is it that people are giving Jaren so much leeway now. Like, I didn't like it with Will Duffy. I don't like it with Jaren. It's like these folks have views that you do not fundamentally agree with, but because they agree with you that the Earth is a globe, you will give them a pass. Yet you won't give others that same consideration. And I find that to be hypocritical, and I have made myself known that I don't appreciate it within the community.
It's very goofy. Yo, let me to drop this on you real quick, right? So I dropped this link. It's just a Wikipedia, but he's talking about Parat and plasma cosmology. And it says he mentions laboratory experiments of Wiston Bostick in the 50s. So I was off at the 60s, but we just discussed that created plasma discharges that looked like galaxies. Parat conducted computer simulations of colliding plasma clouds that he reported also mimicked the shape of galaxies. Parat proposed that galaxies formed due to plasma filaments joining in a Z-pinch, the filaments starting 300,000 light years apart and carrying Birkeland currents of 10 to the 18th amps. Okay, obviously I disavow these something like I don't believe in any of those instances. But anyway, I'm just trying to bring up some of the phenomena here, right? So showing emerging jets. The simulations showed emerging jets of material from the central buffer region that he compared to quasars and active galactic nuclei occurring within supermassive black holes, which I would say is just the center of a magnetic field. Pratt proposed a sequence of galaxy evolution, the transition of double radio galaxies to radio quasars to radio quiet QSOs, peculiar and safe ferrets galaxies. Okay. Oh, and finally ending in spiral galaxies. He also reported that flat galaxy rotation curves were simulated without dark matter. Okay, so who cares? I'm not even condoning that guy's theory at all, right? My point is that it is very interesting that when we can do something here in a lab, and to me, anything is automatically much more compelling when I can actually test it, replicate it, verify the phenomena, right? Because physics scales. So I was like, you're showing like a viability, a possibility. You aren't verifying that's what's actually going on in the sky, of course. But when I'm in a lab and I'm going to use plasma and magnetic fields and I start creating all kinds of different hyper-specific galactic phenomena, right? That mimics it in terms of like, we discussed the different things, right? To me, that's like substantial. And then like I think like your main contention was being like it'd have to be super strong. I don't know that that's necessarily true. Based on say like the speeds. Also think about like if you're actually entertaining this alternative position. Hubble points this out, but if you have a geocentric model, that changes everything. And this changes redshift interpretation and say that they're like velocity shifts or something other than the current interpretation, then it's going to make the universe much more local and much more dense and finite, right? And younger. And so this is going to obviously this is going to have a domino effect on all of the, presupposed, I would say, but interpretations of distances, sizes, et cetera, et cetera. And so we're going to have to automatically make that adjustment in terms of, say, field strength, right? Like it would change everything. So like I would just say a major divide we're going to have is like I'm not going to try to demonstrate that a magnetic field could be X strength based on X distances, X sizes, X speeds needed, right? When I would reject all of those presuppositions. So that's the part. And like you can see why if I'm being very transparent. I feel it's somewhat a futile pursuit to just throw arbitrary numbers on there that are a little closer and a little smaller. Like, what does that really achieve? Right? Like, it's not good. Even if I try to use like the information that's input in the ladder method or whatever, and then reapply them with corrections of a different medium, et cetera, et cetera. Like, not only is that a mountain of work and literally impossible for one person to do, but it would be pointless, right? Because I'm just basically guessing. I'm throwing a guess in there that I actually know isn't right. There's like no way I'm going to get it exactly right. So, is that really worth it? Like, what does that really achieve?
Well, I think the objection that people have, and the objection I have, is that if you're going to criticize something, then and assert that there is a better way, then I'm going to need to see evidence of that better way. Some concrete expectations matching observations, not just it could be this or it could be that. I would like to see these plasma simulations actually match up with data. And apparently, according to the Lerner paper, he does, in the abstract, he does actually state that the model's predictions of quasar energy, blah, 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 are in good agreement with observations. So I'll need to look at the paper and see what he means by that. That's the type of thing that I'm looking for.
Nice.
Yeah. No, and that's cool. That's cool.
So that's sort of, I obviously understand that you aren't going to develop this theory. I understand that most of the folks that I talk to here are not going to develop this theory. But it's more of, again, this confidence that we're wrong and that it's something else. And if you're going to convince me of that, I'm going to need to see evidence of it. Someone is going to have to do it.
So I would say that there is ample evidence that you're wrong, right? Like, obviously, that's my position. And like, and it's like, for one, like we have steps here, right? We have like the mainstream cosmological model. It makes a bunch of claims. And then it's like, okay, let's put this to the test or whatever. And the thing about it is if I go all the way to the base and there are fundamental axioms that are assumed, and any of those axioms are falsified, if I pull that Jenga block out, right? Jenga's not even the best example because you can pull one block out, it still stands. And with some of these things, the whole thing would collapse. And I think that this is the obvious reason that there's such reluctance to even entertain alternatives, bro. Like, for example, with an alternative interpretation of redshift, for example, which is why Halton ARP, I never saw specific rebuttals of his arguments. I saw dismissal, or like the MMX situation, right? And an objectively possible interpretation, right? Like, just objectively possible interpretation of why we didn't detect orbital motion is that there isn't orbital motion. So like if any of these are pulled out, right? And obviously from the geocentric idea, which is what we're discussing, you're pulling that motion out. And that so much cascades off of that. Same with like relativity being pulled out. So much cascades off of that it changes everything. I don't actually need to go through a hyper long list of all astronomical observations and redefine them for it to be falsified, because the fundamental assumptions in which the interpretation of those observations were built upon, in my assessment, have been falsified. and you get that point, obviously, right? And I think that's like there's like ample. I think there's ample examples of this, right? And I think that if we zoom out right now, yeah, we have the cosmological crisis, the Hubble tension problem, and all that. Well, that's just one thing, bro. Like we have like a dark matter, dark energy combined to make up over 96% of the universe problem. We have 83% of the universe being dark matter problem. We have that we did find vacuum energy, tried to apply it to the accelerative expansion, it was off by 10 to the 120th power problem. We have major issues, and I would say we still have issues with the flatness problem, the horizon problem, and many other fine tuning arguments. Have things been proposed to allegedly fix those problems? Sure, but they have just been proposed. Certainly, no one went and found me an inflaton or whatever. So it's like you get my issue. There are undeniably tons of issues, and I would expect. Here's my bigger point I'm making here. I would expect the same good faith acknowledgement of the the pursuit that we have in front of us on the other side. Because what I run into all the time is these people, I'm supposed to just yield. That's how science works. We don't know everything. This is cutting edge. Of course, we're just trying to figure it out when it comes to dark matter, dark energy, and the list goes on and on. Inflation theory, blah, blah, blah. That's how science works. So sure, it's just a theory. Sure, we can't define dark matter. We can't find it, can't define it, don't know what it is. But I'm supposed to just be like, oh, well, that's cool. And that can be a placeholder. That's sufficient. And then someone's like, well, what's your theory then? And then I start, as soon as I start to discuss any alternative possibilities, all of a sudden people understand the concept of being hypercritical, demanding evidence. It needs to be proven, it needs to be verified, etc. There's a total hypocritical double standard. It's like overt double standard, right? Where like, and this happens in this room all the time. Every time someone baits me into discussing my alternative model or a framework, you know what I mean? All of a sudden they're hypercritical, they demand proof of everything. But then on the other side, someone could just go, take a couple tabs of acid and just make up some crazy story about like white dwarfs or whatever. And like,
what's the difference? What's the difference between you and someone that's on a bunch of acid? Like you have no scientific background in discussing the topic. So why do you even attempt it?
So first of all, how would you realize that my background wouldn't equate to me being right or wrong?
3 words into Witsit's point, I knew the auto response carbon copy of what you just said.
You guys, can we kind of maybe let Witsit and Professor Parks kind of complete out the one-on-one?
I'm sorry. Go ahead.
I said a lot to him right there. So like,
we can open it up after, but I just wish
I kind of like the colored commentary though.
Sorry, Gia.
So, as a closing response to what you were saying, is I think I understand your point, and I believe what you're saying. What you're saying is, why is our ideas any crazier than the ideas that are currently being put forward in terms of dark matter? Like one side is saying that dark matter exists and it's composed of axions and all of this exotic matter. How is that any different from saying that actually, no, this is a magnetic phenomenon? And at the core of it, I would say that it's not exactly crazy. For myself, what I would need to see is more papers like this Lerner paper, assuming that this actually turns out to be something. I would need to know what sort of framework, how it would actually explain it. It doesn't need to explain the observations perfectly, but I need to have a kind of a stepping stone. Like for me with dark matter, which I don't think dark matter is a particle. I get the idea of subatomic particles. I get the idea of particles being difficult to find, but difficult to identify. I've seen sorts of examples of that. So it's easier for me to accept that as a proper line of inquiry than just simply a ferrocell. But to your point, I will freely admit, one idea is not necessarily as crazy as another one. For me, though, I need to be able to see a good physical underpinning in order to really sign on to looking at it as a viable option.
Yeah, fair enough, man. I guess yeah, if the room is wanting to close it up, that's cool. I will say one more thing to think about, like even if I jumped over into your paradigm here, and just to clarify, like I'm not saying like it's equally viable. Like my honest opinion is that falsification is independent of replacement. That paradigm's been falsified in many ways, and so maybe it's uncomfortable, and certainly we would disagree maybe, and
Yes.
Whatever. But like, okay, I'm going to toss out a lot of those assumptions because they're tainted. And now we're building back from the beginning. And it's like a lot of the stuff we've discovered is still here. A lot of the observations are still here. A lot of the evidence is still here. They don't just become untrue overnight. A lot of the undeniable physics and evidence that we've incorporated into some of these ideas, they don't disappear overnight, nor are they exclusive to some of these interpretations or some of these philosophical biases, right? But like, we are still having to like, work a new framework now, kind of from the bottom up. And that pursuit exists independent of the previous falsification. And to me, it's like not intellectually satisfying at all. They're just like, well, I want to hold on to it till we come up with something better. I think I get why people maybe do that. There may be some pragmatic reasons, some like, career reasons like that, but I don't care about that. Like that's no good for me. Okay. And to expedite through here, I think that my point is that it's a double standard where anything that's challenging, it's like people are super critical, but as long as you're proposing an idea that would help save the phenomena, and save this model, bro, you're giving free reign, and here's a couple mil, bro. Like, please help us out. And people, certainly in this room, they just die. They just swallow whole whatever idea is thrown out from that side, and then they call it the cutting edge of science. And of course, we don't know things. But then I say, hey, look, I can replicate electrostatics. I can replicate electric fields. I can replicate magnetism. I can show you the formation of what would be a galaxy and the plasma. I can replicate this phenomena in a lab, right? And it's not limited to proportion to mass. It's way more viable because it's way more adaptable and less limited, et cetera, et cetera, et cetera. And like it's like somehow just thrown out, or I need to go up there and get a cup of it or something before it works. I think that's goofy. And then to address the bigger thing with the magnetic fields, I just want to make sure you kind of understand my idea. Even within your paradigm, it's actually more so in your paradigm where these things are huge. We're talking tens of thousands of light years, right? These, like, say a galaxy, like how big it is or whatever. So sure, you could zoom out and say that your spectral readings are correct, and say like we do see some magnetic fields, but they're weak, or there can't be that strong of a magnetic field there because we would see the spectral lines break, right? And like I said, I vaguely remember that there is like a cancellation effect that can happen within these readings when it comes to magnetism and polarization and relative to the plasma and all that stuff. But just set all that aside. Like, let's just say that you're correct about that. Like, if you had a really weak magnetic field, like it's weak in terms of like, say, the micro Gauss or Gauss, right? Like, okay, it's weak in that sense, but that would be somewhat misleading in the way that we're discussing, like, oh, it couldn't cause these galaxies to do what they're doing because it's so big and da da da. But think about it. Think about if you had like this magnetic energy spreading throughout that enormous volume. I think it's much smaller than you think it. I think it's much more local than you think, but it really doesn't matter because it's still big, right? Either way, and you're certainly really big, right? So you're gonna have all this magnetic energy, although the microgauss might be small, it's still spreading through that whole volume, right? And so that's enough, like compounded, right, to basically guide and shape these galaxies because it's like a ton. We're talking like say billions of tons of plasma that's being affected with this magnetic energy distributed throughout it. And this is consistent with what we see in the lab, right? Just like weak fields in plasma cause immense speeds and formations of these different structures that resemble galaxies. So it could be overall, like it could be weak magnetic fields that still result in like extreme velocities and extreme and like massive structures forming and moving, right? And so maybe that is at least something for you to consider where you were, I don't think, I think it's a possibility. You wouldn't even have to throw out some of the spectroscopy readings, and this is still a possible explanation. And now all of a sudden, we're not limited to proportionate mass, and we're freed up, way more freed up. Like it's not even close. That's what I
Are you
mean by
suggesting that we just get rid of data, ignore that it exists?
No, wait, what, Dad? No.
I thought I heard you say throw out spectroscopic data.
No. I'm saying even if you didn't want to, I was saying that way you wouldn't. That way, even if you wanted to keep it on, like within your own spectroscopic data, like it could still be explained because the magnetic field could be weak and still cause the phenomena. That's what I'm saying. So it's like it could be consistent with your spectroscopy.
Again, to be clear, on my position is if the things that you're showing me that there is that magnetic fields could in fact be the cause for galactic shapes and all of this sort of stuff. If it can be developed to the point that it can match observations, and again, according to the Lerner paper, he is saying that he has matched observations, then more power to them. I'm not saying that they shouldn't do this. What I'm looking at is I haven't seen really anyone do this at all. But on the other side, I have never seen a concerted effort not to do it. I have been confronted with that NASA is an atheistic satanic cult that is deliberately attempting to push aside any sort of research that is that would confirm a geocentric universe or a created universe or anything like that. That I strongly object to because I see no evidence of that as someone in the community. Now, going towards an earlier point that you made and the point that Sabine Hostetter made, is the system perfect? No, it is flawed. And when it comes to dark matter, as I've already stated, I think that we need to, from a funding point of view, we need to open up funding to areas of dark matter research that do not involve particle dark matter. I think more research needs to be put into alternative theories of gravity or a reimagining of relativity. I am all for that. But ultimately, it comes down to this stuff has to be shown to match observations and more than just making pictures. It doesn't have like it can't. For me, I'm not satisfied with a qualitative or pictorial match to things. I want to be able to see that the dynamics, the actual motions, the measurement, the amplitudes of the motions, the directions of these motions actually are similar to those that you see in galaxies. So,
well, I appreciate you grabbing all the links, by the way. I gave you the 2 most relevant papers, The Evolution of the Plasma Universe by Anthony Perrott.
Yeah.
I gave you 1 and 2, and then there's more in the chat. If you want to just kind of grab all of them, I did post a lot. But,
yeah, I've got, I don't know how many of these things I've actually downloaded. Where did it go?
I got more coming for you, so I'm basically giving you as much relevant information as possible, brother.
Hold off on that. You've given me plenty to read at this point. So I think if you gave me any more, it would just kind of fall through the cracks. Because
you can read it later. You don't have to read it right away, but I just wanted you to have it.
Okay. It's more of, if you give it to me now, I'm probably going to lose it.
How about I formulate a more specific explanation. Like I typically don't always do this, right? Because I'm a big proponent of like falsifications independent of replacement, and you can get lost in speculation and stuff like that. And so like this is speculation station, and I think it's important to declare. But I will, because I think it would be edifying in general, right? Like create like a much more hyper specific. Maybe we'll pick out a couple galaxies, a couple clusters, whatever, and we'll show the possibility with specificity. So using the Lorentz force, kind of using like electric currents that flow through the spiral arms and create these structures within a plasma medium, right? And those, because the currents would generate magnetic fields, and we can easily put the math to that. Because that's kind of my point, is that the math actually becomes much easier, because when it comes to electricity and magnetic fields, you have a wide range of, moving that relationship around. And when it comes to gravity, you have mass, and that's what you got. You know what I'm saying? So there's no doubt that we can do the math and move the math around. Maybe even just going along with the mainstream claim size and distance and stuff for intents and purposes to just show the viability of it. But anyway, I'll do that and at least be able to like formulate it in a more specific way, if that's what you're asking. Or what I mean, yeah, like I'm not going to build a whole freaking universe model for you or whatever. But I am curious maybe what you would think about that. I'll also reach out to some of my friends I have that are in these fields. That a couple that are off the record, right? And see if they're willing to help me with maybe like wall tackle like a cluster or something like that. I don't know. And then we can progress it that way maybe.
I am all for it. I mean, if you can, if we can start approaching this problem with specificity, I would be very happy. If we can, again, any description of the universe, in my opinion, of reality, in my opinion, is going to have to make some kind of prediction. It's going to have to make some kind of definable, quantitative prediction that can then be matched up to observations. And until I see that match, I'm really not going to put a whole lot of stock in the theory. Obviously, I will say, as a scientist, I have to be open-minded. Sure, there's a possibility it can exist, but until I see that match of data and theory, it's really just quite literally academic.
Okay, cool. Yeah, I mean, Yeah, there already is a lot. I'll send you a couple things.
Like I said, I've got enough to read at the moment, but yes,
No, I know. Like I'll just need some maybe largely visual
bad.
things, right? Like at least
No worries,
it'll like I think it'll at least like kind of solidify some conceptualization, right? Like, because I think in your paradigm, Faraday rotations have been acknowledged to exist, right? Et cetera, et cetera. And so, like, if you look at like, yeah, like the formulation of galaxies and the jets and the arms and the disks, all of this is readily accessible on the lab scale, right? In the lab frame, we see this all the time. Like, we see these phenomena. These are, if I'm wrong and your paradigm's right, coincidentally, gravity has created galaxies and other celestial observations that perfectly mimic electrical and magnetic phenomena when it comes to the structures, the formations, and just the optics. And I mean, that would be interesting, right? But I don't think that's the case. I think that we will eventually, and maybe not in our lifetime, but hopefully, the understanding of the universe will be that it's electric. And the primary causal mechanism of all of this motion observed is electric and magnetic in nature, and that interacts with this plasma. And there may be an underlying tenuous medium that behaves similar to a superfluid. Therefore, it doesn't have a lot of viscosity, right? And thus, it's like it lacks resistance, and these bodies move freely through it, and it interacts within this medium and the plasma, right? And like we're just living in like a freaking yeah, bro, we're living in an electric universe, and we're at the center of it. And I'll say one last thing, and I know you disagree with this, but as far as I can tell, we're on the plane of inertia, the inertial plane, the dielectric plane, through the center of a torus field. We observe the top half of it. This gives us a torus field geometry. So then, of course, we have the centrifugal divergence out from the center. The redshift is proportionate to the distance out away from that center point, which is why we see redshift in all directions. And then that gives you the vortex that would then move around us. And then we've discussed the dynamic equivalence that comes from an angular momentum of a rotating universe, having centrifugal and centripetal forces, centripetal being stronger, it would be perpetual. You would just need some primary mover that started it. And then everything within that torus field is intrinsically electric, following the same fractal geometry. And the actual spiral galaxies, et cetera, are just like we see the vortex in the center of the torus field of magnets. And that's like a very zoomed out meta framework of a geocentric electric universe. I threw in obviously the shape, falsification portion. A lot of this is not exclusive to shape, but I threw it in there. So, yeah, man, I can't wait until that day that you see that that's the case, and then we get to have you on the good side.
Okay, all right. Well, it's going to take a lot to do to get me there, but all right. Yeah, I will look through these papers and one day at a time.
Yeah, but well, nice talking to you always, man.
Yeah, you too.
That was great. And I'm going to compile all of those papers and put them in the PDF resources in Earth Awakenings for later reference, and I'll just label it under Plasma Universe.
Got it. I haven't looked at all these channels, so there's a PDF thing? Oh, yeah, PDF resources. Okay.
Yep. I'm about to compile all of it. I'm just getting all the names.
Oh, wow, yeah. Okay, cool. Now that I know that exists, I'll start looking into it.
Beautiful.
So.
Yeah, man. I'm just saying it's not just like you unless you want to respond, but to everyone, like I keep harping on this because to me it just makes so much sense. And so like I want to hijack Tesla's phrasing here, but like it occurs to my simple mind, right? Like so like whatever, maybe I'm wrong, but we're like when we look out there, we don't see nearly as much of what appears to be visible matter as one would expect, like with the motions that we see. And like something like magnetism has so much easier of a time explaining that. And we can just have a little tiny bit of matter out there and we could still see immense forces like and huge fields and a ton of motion. And so I mean to me it just seems like such an obvious fix. You know what I'm saying? That's why I say the like the dunk on comment, because like I think if we like the whole I'm in the center of the universe, I'm not moving. The earth I live on is founded, and therefore the universe is not accelerating and expanding. So I don't need some energy to make it do that. So dark energy, talk to you later. And then I don't believe the causal mechanism of the celestial motion is gravitational. I reject that outright. So now I don't need the extra matter. So if I throw those two things out, I mean that's like a 96%. Like right now, that composes 96% of the current universe model, and now that's gone. So that's what I mean when I say like it's way more viable. I know
So
there's like a million things you would say need to be satisfied before you could ever get to where you say that's what's happening, but it's just like in the hypothetical, if that like if you zoom all the way out, that obviously is more viable than 96% a giant question mark that we can't find, can't define, has to be there, and we've been looking for a long time. If there is some idea, some framework, some interpretation that's proposed that doesn't require those two things, dark energy, dark matter, it is obviously uh, preferable or more viable, right? It's just all the other components and observations within that, the implications of something like that, that you're taking contention with, and you're basically applying the idea of we're not just going to throw away all of this that does work, right? Before we're able to sufficiently explain the phenomena with whatever alternative is proposed.
Can I ask you a simple question? What's it?
Yeah.
Did Antarctica ruin your life?
No.
Wow.
Antarctica was dope for like a day.
Are you better for it?
Am I better for
gone.
it?
For having
Weird
gone.
questions are these, bro?
Do you feel like your life would be different had you not gone?
Metaphysical.
I mean, that's a super vague question. Like, would my life
What's
be
a tough
different?
question? It's a tough
Would my
question
life
because
no, it's just like
you'd be a
it's
flat
like
earther regardless, right?
super
But
vague
like it
question.
would be, well, you would have a lot more tools at your
He's
disposal.
tilting the
had you not
convo.
gone.
Go on mute.
I would absolutely
honestly,
rather have gone and known. And in that sense, even in a flat earth specific sense, it's way better. Because I would way rather know and have confirmed that the phenomena is there at that location. And I got to, get a passport and then throw Antarctica on it and see something that barely anyone gets to see. Something that was so beautiful and breathtaking in the plane that almost everyone like kind of got emotional in a way, as weird as that sounds. And I got to see that, got to experience it firsthand, got to come back and now know unequivocally that phenomena happens there. And so it incorporates into my understanding of the realm. Whereas I would have just sat here not knowing, right, this whole time or indefinitely. And so to me, that all of that's only good. I don't really care that people freaked out. I don't really care that I got all kinds of death threats or whatever. Like all that stuff in time just makes me stronger. And so like, yeah, I'm totally cool with all of it. That's my answer.
I believe you. I believe when you say that you had the heart fluttering moment because yeah, it's unbelievable what nature has to offer. So I appreciate that.
Yeah. And yeah, for myself, I would like to open the room up too. I think that Witsit and I have hogged the room for long enough. So I'm willing to. Yeah.
It was
Yeah.
enjoyable.
Anybody else got questions for him? I'll fall back also if he wants to do that. Like so we should open it to everybody.
Well, they had that whole conversation. I had one thing I wanted to ask Witsit or Professor Parks, but Witsit, since you were proposing this idea, what you're putting forth in terms of, a new model, paradigm, understanding, etc., however one would word that. My question to you is, if funding was available, now I know the question of how much funding, whether it's 5 million, 50 million, or 500 million, but with funding, in terms of what Professor Parks is asking for, in terms of data and more direct evidence data, et cetera, that would be needed with money, and I guess I'll leave that kind of open as to how much money, because I realize that 100,000 is very different than 100 million. But with resources and money, what do you think you could do in terms of acquiring more evidence and data, more tests? And you can answer it in any way you'd prefer. I mean, obviously that could be a whole conversation in and of itself. But yeah, I'm just wondering what you think of, if funding is available, what advancements you think could be done, and then, and how that would advance things.
Yeah, so I think actually this pursuit wouldn't be extremely expensive relative to a lot of other like because we're talking about just like astronomy, right, or like astronomical observations. Not a place that's accessible, contrary to belief, right? So as far as I can tell, anyway. So it's not like we're gonna like spend a ton of money to go way out there and go see what the galaxy's doing. So really, if you gave me all this money and that's what I could spend it on, I'd be paying tons of people to now reinterpret all the data and evidence we do have, right, and doing like the legwork of running it through the different model or framework or whatever, and then you could throw a lot of money at like replication of the phenomena similar to what they did with this plasma and just modeling out all the phenomena that we see all the observational evidence being satisfied in actual physical replications, I don't think that either one of those things would be extremely expensive. I don't think that what's holding this back is money, right? Like I think it's manpower, and I think it's like intellectual freedom within these worlds, right? So yeah, I mean, I don't know. I just pay a lot of people to freaking reinterpret the data, replicate the phenomena, and then yeah, start to model the phenomena out one by one until you got the full model. So that's literally all you really, I think, could do in terms of this. I mean, you could obviously say you have unlimited money and you don't have like the government to worry about and stuff. You obviously want to go as high as you actually can. And you want to really figure out what the mediums are and the differences in the mediums, etc. But I don't know any limitations that do exist with that, right? So yeah, anyway, I guess that would be my answer.
So
Yeah,
I would
yeah.
say that I actually fully agree with Witsit on this. The data is there. So what you would, from a practical standpoint, where the money would come in is you would need to be able to pay, if you were a faculty member somewhere. I don't know how that would be possible, but if you were a faculty member somewhere, then you would need to have money in order to pay postdocs, postdoc research scientists, and you also have to have money to pay grad students in order to essentially do, as Witsit has just said, take that data and then develop a different model, which then can lead to predictions that can be tested against those observations. So I'm in full
Exactly.
agreement with Witsit on this.
Imagine if you opened up like the dark matter funding, like a portion of that, and you actually paid those people to do that, like pay them with that task, right? Of an electric universe, like explain the phenomena with an electric universe paradigm or like plasma cosmology, whatever, right? Then they would do it. You know what I'm saying? There's no telling what would come out of that. It could truly be something amazing, but that's just obviously so far detached from where the funding actually goes.
Yeah.
So yeah.
No, great answers from both you guys. Appreciate that. So as a follow-up, like what do you think, how does this, I know you guys didn't talk about the shape of the earth too much with all of this, and not to go all into it, but how would this link into that? I mean, obviously you and Professor Parks have a different viewpoint on, the earth and the shape, the heliocentrism versus geocentrism, and the motion, obviously a lot of those components. So, in terms of a new model being developed, in terms of the sky or new understandings and so on, how would that link into the shape? Like, would those come together? Like from the perspective that, of course, that it isn't a globe and that the shape, that the model right now is incorrect on the shape and some of the astronomical. Now I know that could be debated because if folks think it is a globe, then obviously there would be different. But I'm just wondering what you think of how that would play into it. Like would there need to be with a newly developed model? Would that come with how the stars are laid out over the Earth and then the shape? And would there be like a more full model that would end up kind of completing it out when you kind of add the Earth and the sky together in terms of that, in terms of the marriage of the two?
Yeah, so I think like a ton of it would not be shape specific, right? Like all the stuff we talked about tonight, pretty much like any of the interpretations of the actual phenomena. But as to the layout, yeah, there would be a slight difference. Like there are people that propose like a dual pole model, right? For example, like a dual pole flat Earth model. So those are fundamentally different things. That's a fundamentally different um, perspective of an overall magnetic field that you're proposing for the universe. And then you have the other idea, which this is still where I lean, right? Which is like, you have a torus field, you split it in the middle, and there's that plane of inertia right through the middle, and that's where the Earth is. And we're looking up and viewing the top half of the field. And so we're in the center of the torus field. And so obviously those two, for example, are different. And there are ways like that it would factor in, like for the overall model, which we don't even see this much. We see it sometimes, but like rarely do we see the universe modeled as a whole. But like in that sense, then yeah, obviously it would be relevant. But think about this, not as much as you may think. Say you have the idea of a torus field, you have it in the middle, right? And you have obviously like the vortex in the center of that torus field and the Earth's in the very center. Well, I mean, okay, zoom all the way out. Like if it's flat or if it's a ball, I mean, whatever. Like you're in the center of this gigantic torus field that is the universe. Either way, but you get more specific. It's like, yeah, if it's a plane that runs through that plane of inertia, it would be relevant in certain ways. So long story short, maybe not as much as people would think. Like I don't think that the specific topography of the Earth plays a major role with the vast majority of the phenomena in terms of geocentrism, heliocentrism. It does some, not necessarily entirely. Shape becomes somewhat less important as to now the motion is a huge part of it. Huge part of it. Can't be overstated.
You think
So if
more
the
so
Earth's
than
not moving is very important.
more so than the shape in a way, just because
Yes,
the
and
sky,
yeah.
the motion of the sky versus the motion of the Earth is pretty essential in terms of the.
I think so, yeah. Because like if you remove the motion and the Earth's not moving, like I said earlier, then now it's not accelerating. The universe is not accelerating and expanding. Now it's much more local. It's much more dense. Everything is thus smaller. I mean, think about how drastic of a change that is from one paradigm to the other, and that's based all on motion, because the motion has a cascading effect. Because now to explain why it looks like we're in the center of the universe, we're not saying it's an illusion, we're saying it's an actual observation. So now it's, redshift accelerative expansion changes, and now that has a huge effect on everything else, brings everything in, makes things more dense, et cetera, et cetera. So yeah, like to me, that's like way. And then of course you don't need relativity to explain MMX at that point. So now that relativistic paradigm, if you take that out, obviously all of physics almost runs through the relativistic paradigm at this point until you get into quantum, really. So it's like that's going to change everything, and now you're going to explain phenomena. Either you're going to come up with something else that explains all the stuff gravity does, or you're going to explain the phenomena independently, which is what I would propose. I'll say this one last thing. Because a lot of people get confused and they're like, if I start bringing up magnetism about a galaxy, they're like, oh, so you're saying, you're so easily debunked because magnetism is not what makes things fall. Or when I drop diamagnetic material, it wouldn't fall at the same rate. It's like in your paradigm, gravity is the same thing on Earth that makes things fall on Earth and the same thing that makes those galaxies move. But that is just an assumption that you're trying to put on me, right? Where magnetism could be causing the movement of the galaxies. And then another one of these celestial motions could be electrical currents or eddy currents or whatever. And then what drops on Earth could have nothing to do with like literal magnetism, right? They're independent of each other. So yeah, I'm saying all of those things I just discussed is basically changes all of physics. And it's just about the motion. We haven't even got to the shape yet.
So I have a question, Professor Parks, because this is my area of expertise, and I hope it doesn't trigger the entire room because I know how sensitive this subject can be. But earlier you mentioned that you get attacked quite often for the rumors around NASA and its personnel, and you said that they're simply not true because you are in the community. Like, what is your actual stance on that?
Stance on what specifically?
NASA being overall a company that is engineered to deceive the public on the actual structure of the Earth and the cosmos itself.
I don't believe that at all. I do not believe that NASA is something which has been designed to deceive. One, I don't think it's deceiving anyone. At least it's not purposefully deceiving people. NASA has been wrong, but I don't think it's deliberately deceiving people. And I don't believe it has been engineered to do that.
Yeah, Lon, you got any evidence that they've been deceptive from your point of view?
I don't really want to get into a long drawn-out discussion about that, but I understand names and breakdown of languages and how things get changed over time. And of course, there's also the evidence that we have on our side that says that there are a lot of things that have been lied about that are pretty major, So I just wanted to. He says,
yeah, one example would be fine.
I mean, most recently, I'll use something recent, not something old. Most recently, we had a team of astronauts that explicitly said that their mission, first time that you're going to have human beings on the moon, first time that you're going to have human beings in low Earth orbit. Now, unless that astronaut misspoke and they just never corrected him. That was live.
Sorry, I'm sorry. Repeat that again.
Most recently, there was a panel for a team of astronauts. I forget which group it was. I have to find the video again. I do have it on my YouTube somewhere buried in the plethora of videos I have. But he said about 42, 45 minutes in that this mission that they're going on is the first mission that they'll have with human beings in low Earth orbit and possibly the first mission they'll have with human beings on the moon.
Okay. I mean, I of course would need to see it and get the full context of it before I would give it.
I can find it and I will send it to you. I know you already have like a plethora of things that you probably have to look through though.
Yeah, that I will put on the top of my list. I mean, if
that's engaging.
So, if you were saying that NASA is out in the open, has admitted that the Apollo landings weren't a thing, that's definitely something I want to look into.
Are you sure they weren't just saying, like, if it was like the Artemis program or something, that they were just saying that maybe that for them it would be the first, for the Artemis, maybe the first Artemis to do it?
It's quite possible to argue that way, but the way he worded it did not make it sound like that. So again, maybe he misspoke and no one corrected him, or just his wording's off. But it's just been a few times other than that same kind of statement has been made. Not to mention some of like the older stuff where the NASA official comes out and says, "Oh, the reason why we don't go back to the moon is because we lost that technology or it was destroyed," which I think is absolutely wild.
That's not exactly, that's misunderstood, that quotation. So the parts needed to build a Saturn V rocket are pretty much bespoke. And so the technology that was destroyed was the machining, the machines used to create the parts for a Saturn V rocket. Does it mean that we could never build it again? No, that is not what that person meant by saying that. They're just saying that we would have to basically we would have to build up the machines in order to build the pieces that we could put together for Saturn V. The ultimate reason why we didn't go back to the moon is money. If you look at the Apollo program, the United States is spending about 4% of the GDP on the Apollo program. After the last Apollo mission, when the government basically said this is no longer needed as a propaganda tool, the funding dropped down to, I think, around 0.4% of the GDP. So there was not the money to go back to them.
Okay, cool. All right. That's actually a better explanation than I've gotten before. One other question, and this is more of just like me kind of picking your brain on this subject. So I am a flat earther. I am a biblical flat earther. I believe that there's water above us. And when you look at some of like, say, SpaceX's rockets, how they go up and they go up in an arcing fashion, and it appears to me and a lot of biblical flat earthers that this rocket is skimming across water, much like you would if you were to fire off a firework on water as well.
Okay.
What
I think I know what you're talking about. And so that would be, if the phenomenon you're talking about is the one that I'm thinking of, then what you're seeing is air at that location, or air in that circumstance can act like a fluid, and fluids can behave in similar ways. So if you're talking about like bow shocks and trails coming off the rocket, then that can be explained by airflow, assuming I am talking about the same thing you're talking about.
Okay. That's all I had, guys. Thank you.
And I am still compiling all of those PDFs and naming them properly with dates and everything. It's going to be a good chunk. I was supposed to go to sleep like an hour ago, but
Yeah,
I probably Professor Park.
I appreciate that. Yeah, I probably should get something to eat or drink. To the person I was just speaking with, can I ask? I would like to ask you the question. You said you're a biblical flat earther. What? Yes. I'm assuming you take the Bible literally as written in English.
Yes.
Okay.
The parts that are descriptive are supposed to be taken quite literally to what it says. Yes.
Okay.
I also do not deny
the entire Bible literally.
Well, to say that you take the entire Bible literally, some people tend to think, oh, so that means you're supposed to actually eat Christ's flesh. That's not how that works.
Okay.
But yes, I take the Bible quite literally.
Do you mean that when people say they take...
I also don't exclude the Book of Enoch like most people do.